Night in deep space is not silence. It is a pressure that gathers at the edges of seeing, a hush that thickens until the mind feels it like cold glass against the skin. Somewhere in that pressure sits a region without face or texture, a place where every line of light bends inward, as if remembering an older command. The stars seem steady in their distances, yet at scattered coordinates a boundary is drawn that no voice crosses. It is not painted or stacked from atoms. It is a rule written into the way things move. He drifts there in imagination, a witness without breath, and the sky folds down around an invisible centre. The nearby starlight grows restless. Colours retreat into deeper red, then into tones the eye can name only as absence. Around the hidden heart, a ring of gas glows like a storm set on a record player, sliding faster with every loop. The temperature climbs to the millions, then the billions, and still the ring holds because the centre asks for more. The glow is not a beacon of safety. It is the scream of matter losing its shape. A black hole is not a hole, not a pit carved through cosmic floorboards. It is a region where gravity becomes instruction, not suggestion. Every path that might have led away turns back. An event horizon forms, a strange coastline with no beach and no water. Nothing that sails across returns to speak of what it saw. The horizon does not kill. It records a final choice made by light and by anything with mass, to fall deeper than time can reverse. Near that edge, clocks misbehave. A second for the distant galaxy is not a second here. The rhythm of cause and effect stretches thin, like silk drawn from a cocoon, until the thread threatens to vanish. Photons leave late and arrive later, their energy drained by the climb out of this steep valley. The redshift is not a trick of lenses. It is an exhaustion printed into the flight of light, a receipt stamped by gravity. The nearer the witness drifts toward the border, the slower the universe appears to breathe. What waits inside cannot be sketched with ordinary lines. The equations point toward curvature that grows without restraint, toward a place where distance collapses and direction loses, meaning, if space is a fabric, this is where it is pulled through the needle's eye. The singularity hides not out of malice, but because description fails. Scales break. Coordinates lose patience. Matter forgets its own alphabet. The mind, trained on surfaces and volumes, falters before a density that has no floor. Around the dark centre, a choreography unfolds. Gas that once wandered between stars discovers the gravity well and spirals inward. Friction turns the spiral into a furnace. Magnetic fields twist like taut ropes and snap, flinging sparks across the void. Jets launch from the poles, thin as needles and longer than galaxies, drilling through intergalactic night. From afar, the system looks like a crown of fire poised above a shadow that will not yield its profile. The terror is not the violence alone. It is the eerie cleanliness of the appetite. Nothing personal, only the pure arithmetic of fall and feed. He considers a traveller made not of flesh but of idea. It carries within it the inventory of a life, the arrangements of memories and names that once adorned a city on a gentle planet. As the traveller coasts toward the gravity well, it sees the universe slow to a reluctant crawl. The far constellations fix themselves like icons on a frozen sea. But to the rest of the cosmos, the traveller pauses and fades at the horizon, never quite crossing, never quite gone. Two stories coexist, both obedient to the same physics, each faithful to its own clock. The neighbourhood around the hole is a study in paradox. Heat blazes, yet the source refuses to shine. Motion accelerates, yet the centre seems still. Structure forms in the very act of dissolution. The black hole sculpts its environment, shepherding stars, choking or igniting the birth of new ones, carving channels through interstellar gas. The galaxy carries this hidden engine like a secret vow, its spiral arms arranged around a power that does not advertise itself, except through the behaviour of everything else. Fear arises from more than tales of spaghettification and crush. It grows from the confrontation with limits. Human thought likes horizons it can step around. Here, the horizon is a principle. No instrument returns with a map. The insistence of the unknown is total. The rules seem to invite approach with the same patience that forbids return. The whole is an object, yet it feels like a sentence, a clause that ends with a period heavy enough to bend grammar into a circle. The sky near such a beast flickers with rhythms both swift and irregular. X-rays pulse as knots of gas collide and shear. Infrared glows like the red memory of a brand. Radio waves draw outlines of jets that pierce distances no human hand will ever span. In that symphony, the black hole is the conductor who never raises a baton, who never appears on stage, who nevertheless holds the tempo with absolute grit. The instruments do not resist. They cannot. Their music is acceleration and fall. He realizes that terror here is a cousin to awe. The blackness is not empty. It is thick with consequence. It gathers the laws that bind the cosmos and distills them into a simple imperative. Cross the horizon and continue inward. Radiate at the margins, but surrender depth. Offer form and receive simplicity. Space and time trade properties in a ledger no one else can read. The wonder is in the clarity. The fear is in the clarity as well. A final image lingers. A star drifts too close, its calm surface stirred first by tides, then torn to ribbons as if a patient hand were unweaving it. The ribbons form a glowing loop that snaps and smokes, then pours in as a bright river. For a brief season, the galaxy wears a new jewel, a flare that says a change has happened in the ledger of mass and momentum. When the flare fades, the whole is heavier, not transformed, only more itself. It keeps no trophies except the numbers that define it. The watcher recedes from the imagined brink. In the mind's rear view, the ring of fire shrinks to a wafer of light suspended on nothing. The night closes again, smooth as lacquer. Yet the shape of the hush has changed. Knowing that such regions exist alters the quiet. It turns the black between stars into a map full of warnings and invitations. Somewhere ahead, a gravity well waits with the patience of stone. It asks no questions and gives no answers. It only curves the world until every path becomes a yes. The story begins in chalk dust and wartime gloom. In 1916, Karl Schwarzschild, stationed on the Russian front and weakened by illness, solved Einstein's field equations for a point mass. His letter to Berlin described a geometry where space folds so tightly that even light would have no path outward. The mathematics did not shout. It spoke with cold certainty. A radius emerged that acted like a gate. Cross that distance, and all trajectories tilt inward. The idea felt like a riddle set by nature using geometry as the punchline. Skepticism was immediate. Stars seemed too stable, too polite to collapse into such extremes. Astronomers worked with spectra and delicate measurements of parallax. Nothing in those tools suggested a night filled with invisible traps. The next hints arrived not from lenses but from theory. Subramanian Chandrasekhar calculated in the early 1930 seconds that white dwarfs could not grow beyond a mass limit without losing stability. J. Robert Oppenheimer and Hartland Snyder went further in 1939, showing that a massive star exhausting its nuclear fuel could implode without a halt. In their equations, time for a distant observer stretched at the brink, while the collapsing matter continued inward. The paradox felt almost theatrical. The mathematics refused to blink. Language needed to catch up. John Wheeler gave the object a name in the late 1960 seconds that suited its appetite and its invisibility. Black hole was a phrase both simple and exact. It invited attention. It also invited evidence. The cosmos obliged through a new window. X-ray astronomy, born with sounding rockets and orbiting detectors in the 1960 seconds, revealed hot gas blazing near compact objects. In 1964, a source in Cygnus announced itself with persistent X-rays too bright to come from ordinary stars. A companion star's wobble betrayed the mass of an unseen partner. The measurement said too heavy for a neutron star, too dark for anything with a surface. a candidate emerged in hard data, not just in ink. Meanwhile, a different mystery flared in radio maps and photographic plates. Quasars glared from the early universe with luminosities that dwarfed galaxies. Their light carried the telltale shift of great distance. Their power required engines capable of extracting energy with ruthless efficiency. Accretion onto a massive compact object answered with spare eloquence. Matter spiraling inward could convert a large fraction of its rest mass into radiation. Jets that lanced through intergalactic space completed the picture. The engine looked like a black hole wearing a crown of magnetic fury. The geometry itself grew richer. In 1963, Roy Kerr found the exact solution for a rotating mass. The result described a spacetime where frame-dragging twisted nearby motion, compelling matter and light to follow the spin like leaves caught in a whirlpool. Rotation sharpened the expectations for real objects, born from collapsing stars or accumulated gas. No isolated mass in the universe is truly still. Spin is the rule, not the exception, and it writes its signature into the orbits of everything that dares to approach. Direct mass measurements followed the light. In a nearby galaxy, water vapor molecules in a thin disk around the nucleus produced microwave maser emission. Interferometers mapped the velocities of those bright spots with exquisite precision. The rotation curves pointed to a dark central mass millions of times heavier than the Sun confined within a region smaller than a solar system. Precision removed ambiguity. Alternatives such as dense clusters of dead stars could not pack tightly enough without evaporating through gravitational encounters or producing detectable light. Closer to home, a quiet radio source at the center of the Milky Way became an arena for patient watching. Over decades, teams traced the orbits of stars that swung through the inner light years, like comets around a bonfire. One star, S2, completed a full loop in roughly 16 years. Its speed peaked a few percent of light. The shape of its path and its precession matched predictions for motion in a deep relativistic well. The unseen mass measured in millions of suns could hide within no cluster without tearing itself apart. The verdict pointed to a supermassive black hole anchored in the heart of the galaxy. Another messenger arrived across a continent of vacuum. Gravitational waves, once a whisper predicted by Einstein, rippled through space-time from pairs of black holes in their final embrace. Interferometers with arms, kilometers long, recorded minute stretches and squeezes as mergers released energy on a scale that mocked any human metaphor. The waves carried not images but stories of mass and spin. They revealed populations of black holes heavier than those known from X-ray binaries and hinted at formation channels shaped by stellar evolution, dynamics, or primordial conditions. The universe began to speak in a rhythm both violent and exact. Light itself sketched the silhouette. Very long baseline interferometry, a technique that turns Earth-sized arrays into one gigantic eye, traced the brightness around a central darkness in a galaxy far beyond the Milky Way. The pattern matched a lensed ring predicted by ray tracing through a curved geometry. The diameter agreed with the mass estimated from stellar motions and gas dynamics. The image did not show a surface. It showed absence shaped by gravity. It was a photograph of a rule. A second target yielded to the same method. The bright dust and gas near the Milky Way's center fluctuated quickly because the region is small and the orbital periods are short. The reconstruction demanded algorithms that could tame a scene in motion. Yet the result again was a ring encircling a shadow, consistent with a compact mass that curved spacetime into a funnel. No ray escapes. Telescopes that once collected only brightness now rendered geometry with enough fidelity to test the very form of the field equations. Across the spectrum, signatures align with this portrait. X-ray spectra display iron lines, broadened and skewed by velocities near light and by gravitational redshift. Timing studies show flickers with preferred timescales set by innermost stable circular orbits. Polarization traces the dance of magnetic fields threading plasma near the limit of survival. Radio jets reveal collimation that points to rotation and to magnetized extraction of energy from the disk or even from the spin of the hole itself. None of these signposts works alone. Together they map a neighborhood carved by a presence that refuses to shine. What once sat in a notebook has become a census. Stellar mass black holes arise at the end of massive star lifetimes or in collisions within clusters. Intermediate mass candidates hide in dense star-forming regions and dwarf galaxies. Supermassive black holes weigh anchor in the cores of most large galaxies, sometimes feeding with fury as quasars, and sometimes fasting for eons. Their growth histories mark galaxy histories, their feedback throttles star birth, and their mergers rearrange stellar neighborhoods. The objects have moved from theoretical curiosities to primary actors in cosmic evolution. Language keeps evolving as evidence deepens. Event horizon is no longer a metaphor. It is a measurable boundary, with a diameter inferred from orbital dynamics, silhouettes, and timing. Singularity remains a warning label for a place where the theory asks for more. Spin is a parameter recovered from spectra and from waveforms. Mass is weighed by orbits, by reverberation, by the size of a shadow. Temperature and radiative efficiency describe the furnace at the edge. Models that once lived in blackboards now trade predictions with observations written in photons and in space-time strains. The journey from equations to shadows has redrawn the map of the night. It began with a soldier physicist solving a fresh set of laws under an overcast sky. It grew through a century of telescopes that learned new senses, through detectors that measured displacement smaller than a proton, through collaborations that stitched continents into a lens. The destination is not a portrait of a creature in light. It is the outline of an absence that sculpts everything around it. The invisible became legible, not by shining, but by making the universe around it speak. He had written a theory to make gravity simple again. Not simple in arithmetic, but simple in principle. Mass and energy tell space-time how to curve. Curvature tells matter how to move. From those sentences, a fabric emerged that could explain the precession of Mercury, the bending of starlight, the slow drifts of clocks in a gravitational field. The field equations did exactly what he asked of them. They did something else as well. They permitted objects so compact that the geometry itself became a trap. The mathematics implied a region where light cones tilt so far inward that every possible future points deeper instead of away. Elegance carried a secret that felt like a mistake. Einstein favored continuity and balance. The vision was of stars held up by pressure, of orbits drawing patient curves around shared centers, of waves moving through space with a finite speed that guaranteed cause would never outrun effect. The field equations, however, are impartial. Feed them enough mass in a small enough volume, and they bend the metric into a funnel with a one-way flow. Call the boundary an event horizon. Outside it, lines of escape exist. Inside it, none can be drawn. The result does not depend on matter's texture or on the details of nuclear furnaces. It arises from geometry, from the way distances and times must be measured when gravity grows fierce. Calculations soon revealed that this boundary is not a quirk of coordinates. Transform the description, and the feature persists. Birkhoff's theorem removes excuses by proving that any spherically symmetric vacuum around a compact object must adopt the same form. Revolve the equations in your hands, and the same radius appears. The surface is not made of anything, yet it behaves like a gate that never opens. The field knows where it is, even when no observer can touch it. That knowledge unsettled the mind that loved clocks and rulers and intuition, for it suggested an invisible architecture more relentless than any mechanical model. He sought escape routes. If matter could veto the collapse, perhaps the monsters would remain drawings on paper. Pressure was the first candidate. In ordinary stars, pressure is a rescuer, pushing outward against gravity as fusion releases energy. Relativity complicates this comfort, since pressure itself gravitates. Squeeze a gas, and the effort that resists collapse adds to the burden that pulls inward. The Tolman-Oppenheimer-Volkoff equation lays out the balance for an idealized star, and marks a boundary beyond which no equation of state can keep the fabric from continuing to fold. Past that line, resistance strengthens the enemy it means to stop. Another worry was singular behavior. The equations predict regions where curvature grows without bound and geodesics end in finite time. In a deterministic universe, such places look like broken hinges on the door of prediction. Einstein and Rosen tried to reinterpret the interior as a bridge to another region, hoping that geometry would cure the explosion in curvature by opening a throat. The bridges were not stable under realistic conditions. Even if momentary, they indicated that space-time might allow connections stranger than Euclid permitted, yet they did not remove the core discomfort. A theory that replaces one impossibility with another offers little peace. Skeptics proposed that symmetries in toy models caused the pathology. Real stars rotate, carry magnetic fields, and have layers. Rotation could flatten a mass and sling some material outward. Perhaps the centrifugal effect would steady the core. Then Kerr found the exact rotating solution. The effect of spin is to drag nearby frames of reference, forcing everything to twist around with the mass. A new horizon appears, and outside it, an ergosphere where nothing remains at rest relative to infinity. The details grow richer, but the imprisonment persists. Centrifugal support weakens near the center, and rotation refuses to rescue the core from its fate. The decisive change arrived with a theorem rather than a telescope. Penrose proved that once a trapped surface forms, geodesics cannot be extended in a complete way. No assumptions about symmetry are needed, only energy conditions that ordinary matter satisfies and a space-like surface compact enough to turn all future pointing paths inward. The result does not rely on equations of state or delicate balances. It is a topological statement sewn into the fabric of relativity itself. Hawking adapted the logic to cosmology, showing that expanding universes of reasonable kind must spring from their own singular start. The same mathematics that made planetary motion beautiful insists that extreme curvature is not a mirage. This inevitability explains the flinch. Relativity is a continuous theory. It trades the Newtonian force for the shape of the stage. In this play, fields are smooth, differentiable, and proud of it. Singularities feel like intruders that expose the map's edges. They declare a limit to the predictive power of otherwise exact laws. The philosopher inside the physicist resists that conclusion, preferring worlds without edges. Yet the equations that replaced action at a distance with geometry are the ones that paint the corner. He trusted those equations when they guided light around the Sunday. Doubt appeared when they led into regions where cause and effect are trapped like moths in a lantern. Even without the singular point, the horizon itself challenges intuition. It is a surface defined not by local measurement, but by the global structure of space-time. To decide whether a point lies within the region of no return, one must know the entire future of the universe and its causal structure. The boundary is teleological. This runs against a preference for local rules that depend only on nearby fields and their derivatives. A scientist who valued operational definitions found little comfort in a surface that no instrument could identify without an overview no observer possesses. The discomfort is understandable. It is also misplaced, because practical substitutes exist in the form of apparent horizons that a given slice of space-time can reveal. The theory provides tools, even if the ideal boundary lies beyond direct capture. There is a further aesthetic conflict. Black holes are as featureless as the theory allows. Aside from mass, spin, and charge, no degrees of freedom survive. The collapse erases the history of what fell in. For a physicist who celebrated invariance and symmetries, this economy might have pleased. The cost is paid in questions about information and its conservation. If two bodies with different compositions end in the same final state from the viewpoint of classical relativity, what becomes of the distinctions once cherished by chemistry and nuclear physics? The purity of the result risks a quarrel with the broader expectation that the universe does not throw away detail without a trace. Time behaves strangely near the border. Clocks in falling reach the horizon in finite proper time. Clocks far away watch the same fall grow slow and dim, the light reddened until it vanishes from any finite bandwidth. The coexistence of both accounts is not a contradiction. It is the geometry speaking two languages at once, each bound to its local time. To a mind tuned by trains and synchronized watches, the picture feels like a riddle with no human scale. The theory answers precisely, yet the answers disturb because they define natural storytelling about beginnings and endings. Einstein preferred the universe to be hospitable to understanding. He used physical reasoning to guide mathematics and distrusted conclusions that lived only in symbols. The monsters felt like products of extrapolation rather than of labor in a laboratory. It took generations of evidence and rigor to show that the extrapolation was faithful to reality. The reluctance was an honest reaction to an honest surprise. It measured the distance between the worlds we evolved to imagine and the worlds the equations insist are possible. The same field equations that yielded gentle precession and gravitational lensing carry instructions for collapse that does not stop. They do not demand cruelty, they demand consistency. Mass concentrated too tightly curves the measuring rods and the ticking clocks into a trap. No appeal to taste overrides the geometry. The surprise is not that the theory predicts such regions. The surprise is that nature makes them so often that they shape galaxies, stir jets, and punctuate the sky with flares. The reluctance fades only when one accepts that the simplicity he sought has two faces. One shines as clarity. The other is a darkness that preserves the rules with perfect devotion. He cherished a universe that made sense to the patient mind. Curved geometry replaced invisible forces. Clocks told honest time when placed in careful hands, and the orbits of planets became poems written in calculus. Then the equations he had summoned opened a door he did not wish to walk through. In their exact language, mass condensed beyond a certain threshold forces the light cones to tip, futures terminate inwards, and escape becomes a story with no last page. The prediction was not a flourish, it was the sober conclusion of a theory that otherwise restored elegance to gravity. The shock lay in how quickly the mathematics outpaced intuition. Space and time, stitched together into a metric that measures intervals with exquisite fairness, can be driven to extremes by concentration of matter. The solution presented by a wartime astronomer set the scale with brutal clarity. There exists a radius where outward paths turn traitor. Cross it, and every possible motion aims deeper. The surface carries no atoms, no charge, no texture. It is a boundary written by causality itself. A scientist who respected operational definitions struggled with a horizon that cannot be touched and yet commands everything that approaches. He knew stars as balances between pressure and weight. Fusion in their cores provides outward push. Gravity gathers everything inward, and stability is their truce. Mature equations removed much of the superstition about celestial fires. They did not offer reassurance for all masses. When pressure becomes intense enough to gravitate, the very agent that once saved the star adds to its burden. The equilibrium is poisoned by its own medicine. This was not the friendly cosmos of springs and orbits. It was a theatre where resistance can feed collapse, and where a deeper logic buries the instincts of the engineer. There were heroic attempts to evade the abyss. Perhaps the pathology came from symmetry, from the idealized spheres of blackboard stars. Real objects rotate, carry magnetic fields, and possess layered interiors. Rotation seemed promising to a mind that trusted centrifugal support. Then the exact rotating spacetime arrived as a finished sculpture in algebra. Frame dragging took the stage, twisting nearby motion until even the idea of standing still lost meaning. A new region appeared, an ergosphere where nothing remains at rest relative to the far universe. Yet despite the fresh architecture, the trap persisted, and no turn of the dial released the prisoner. Even the singular point, the place where curvature climbs without bound, offended the aesthetic that loves smooth fields. A theory that had united gravity and geometry suddenly signposted a region where prediction breaks. Detours were explored. Bridges were suggested, throats between domains, technical constructions that hinted at passages rather than catastrophes. Under realistic conditions, they collapsed like paper tunnels in a storm. The mathematics kept returning to the same unornamented verdict. Enough mass in a small enough volume creates a domain where the rules permit no reprieve. Colleagues shared the unease. The culture of the time favoured stars that died with decorum, leaving behind dense embers but not tear in the script. Chandrasekhar's limit already strained temperaments, for it forced a ceiling on white dwarf stability that defied comfortable analogies. When relativistic collapse was worked out with clarity, it read like a play that refuses the curtain call. Outside observers see an object fade and stall near the boundary, its light reddening into oblivion. The falling matter experiences the crossing in finite time and continues inward. Both narratives are true, each loyal to its clock. The duality disturbed those who preferred a single theatre and a single tempo. A deeper jolt came from the recognition that the horizon is global in definition. To know whether a point lies inside the region of no return, one must know the entire causal future. Such teleology vexed a thinker who trained himself to measure with rods and clocks at hand, not with an omniscient view of space-time. The pragmatic compromise of apparent horizons answered operational needs but did not soften the conceptual blow. Gravity had become a storyteller with a plot that depends on pages yet to be written, and that is a hard lesson for a discipline that prizes local laws. The simplicity of the final state delivered another bruise. If the exterior is characterized only by mass, spin, and charge, then the complicated stories of what fell inward are erased from the outside view. The universe, generous with textures and histories, appears to compress them into a mere handful of numbers. For a mind that worships invariance, this economy was beautiful, yet it flirted with the sacrilege of information loss. He preferred a cosmos where distinctions matter, where the identity of a thing is not surrendered without a trace. The object predicted by his own field equations seemed to live by a colder ethic. Evidence eventually joined the argument, and each fragment carried its own small shock. Compact sources hurled X-rays across the sky, with temperatures reached only in violent furnaces, while companion stars orbited unseen masses too heavy for ordinary remnants. Quasars burned with efficiencies that classical engines cannot approach, as if matter falling inward were paying out energy with ruthless interest. The new solutions that included rotation proved no sanctuary. They offered more ways for nature to reveal its appetite, including the extraction of rotational energy by magnetic fields that twist plasma into colossal jets. The theoretical discomfort met an observational insistence. Then came the theorems that left little room for taste. Once a trapped surface forms, geodesics cannot be extended without encountering incomplete edges. The conclusion rests on modest assumptions about energy and differentiability, not on fragile symmetries. Space-time itself conspires to create regions where the story of a particle ends in finite proper time. The same mathematical machinery that had welcomed the bending of light by the sun now insisted that collapse is not a fiction but a generic outcome when conditions are right. A theory held dear for recovering the gentle beauty of celestial mechanics was obliging in a harsher register. At the heart of the shock was a collision between two visions of nature. One vision prizes continuity and clarity, a world whose extremes remain polite enough for reason to follow without stumbling. The other vision accepts that the laws, if taken seriously, may drive reality into domains that mock human intuition. The field equations belong to the second vision when pushed hard. They reward trust by making correct predictions about mundane phenomena. They also demand that we face structures that cannot be domesticated by metaphor. The result is a cognitive whiplash that any honest theorist would feel. There is a subtler affront as well. The border is not a wall, yet it edits the universe with authority. Causes inside cannot cast effects outside. The space of possible influences is truncated by pure geometry. That reshapes the moral of physics, which had long taught that given enough time and precision, an observer can reconstruct origins. The horizon enforces a privacy no appeal to cleverness can breach. For a tradition that equates science with limitless transparency, this is a chastening boundary. Even language strains, and that is part of the shock. A whole that is not a whole, a surface that is not a surface, a shadow cast by absence rather than by obstruction. These are not evasions. They are the most accurate nouns available for a reality that refuses familiarity. The intellect that sought exact words for subtle ideas found itself inventing new phrases, only to watch them turn metaphorical under pressure. It is difficult to love a prediction that pushes grammar until it creaks. Yet the same economy that unsettled also promised power. If the exterior is specified by a few numbers, then measurements of motion and light could, in principle, recover those numbers with precision. A frightening object can be cleanly described. That was not comfort enough to erase the flinch, but it planted the seed of a different response. Perhaps the fear belonged less to nature and more to expectation, less to the cosmos and more to the stories humans told about order. The theory had asked to be beautiful and had kept its promise. It had also asked to be obeyed without negotiation. In doing so, it sketched entities that would dominate galactic centers, sculpt jets longer than constellations, and mark the sky with violent whispers. The surprise was not simply that such entities could exist. The surprise was that they are common, a fact that reinforces the original shock each time a new measurement aligns with the old geometry. The mind that gave the equations to the world would have recognized the integrity of their verdict, even if his first instinct was to look away. A star ends like a cathedral closing its doors, the choir spent, the candles guttering, the stones still warm from centuries of prayer. In the deep interior, the furnace that held gravity at a respectful distance cools. Ash becomes iron, fusion can go no farther, and weight reclaims the throne. The core shrinks with a speed that defeats thought. Electrons yield, protons swallow them and turn to neutrons. Neutrinos flee by the trillions, and for a bare instant the crushed heart rebounds with a shock that rattles the star's layers. Sometimes the shock stalls and matter continues inward. Sometimes the shock staggers outward and tears the envelope into glowing petals. Either way, the center chooses a dense fate. If the mass is modest, a neutron star holds the line with quantum pressure, a city-sized relic of nuclear matter. If the mass exceeds that discipline, gravity completes the sentence, and a stellar mass black hole is born. This first rung on the ladder is not a curiosity. It is a manufacturer's standard item sent out by the cosmos in batches. Massive stars live fast and die abruptly, and entire spirals glitter with their memorials. In close binaries, the new hole captures a companion's wind or steals from its surface, and an accretion disk forms like a molten collar. The infall heats to X-ray temperatures and flickers with disturbances near the last stable orbits. The companion wobbles, its spectrum shifts, and the mass of the hidden partner can be weighed. The numbers often point beyond the maximum mass of a neutron star into the realm where gravity refuses all surfaces. The deaths that crown galaxies are apprenticed to these smaller endings. Growth follows appetite. In young star clusters where the density is high, massive stars edge together like crowds at a festival gate. Collisions knit them into a single swollen object that lives briefly and collapses. The merger product can place a heavier seed into the cluster core, a candida in the middle ground between stellar remnants and the giants in galactic centers. Intermediate mass black holes reveal themselves as rumors carried by ultraluminous X-ray sources, as whispers of heavy motion in dense cluster hearts, as dynamical hints that a few thousand solar masses sit in compact authority. The evidence is cautious, yet the cosmos rarely leaves such a useful rung out of a ladder. Another road to heft comes straight from the furnace of the infant universe. When the first galaxies were little more than knots of gas and dark matter, some clouds may have avoided fragmentation and star birth. If cooling was suppressed by radiation that destroyed molecules, the gas could collapse as a whole. Without a tribe of smaller stars to sip from the reservoir, a single object gained the feast. The result would be a direct collapse black hole, a seed already as heavy as 100,000 suns, sinking to the center where gravity naturally herds mass. From there, the path to emperors is shorter. Feeding is not a gentle pastime. Gas arriving at a black hole does not drop like a stone. It keeps the angular momentum it gathered from the clumsy ballet of its past, so it must swirl inward in a disk. Friction inside the plasma drains that angular momentum away and converts it to heat. Radiation fights the inflow, pushing outward on dust and ions. If the rate rises high enough, shining itself becomes an obstacle to eating. Yet geometry and clumping can cheat the limit. Thick disks, optically trapped funnels, and chaotic streams allow matter to slip past the light it generates. In crowded galactic centers, the buffet is generous, and morning never comes. Galaxies do not live alone, and neither do their central engines. When galaxies merge, their black holes fall toward the new shared core, trailing wakes as stars and gas rob them of momentum. A binary forms, tightens, and hardens through gravitational encounters that eject stars to the outskirts, as if flipping cards off a deck. When the separation shrinks to a scale where the orbit radiates energy through spacetime itself, the endgame is quick. The pair coalesces in a final rush that sends a pulse through the universe, and the remnant receives a recoil from the asymmetric waves. Sometimes it leaps from the nucleus and wanders. More often it stays to reign, swollen by the union and ready to feed again. Hierarchy is the law. Small holes make medium ones. Medium holes join to forge the giants. The giants carry titles carved in dynamics. In many galaxies, the mass of the central black hole correlates with the velocity dispersion of the bulge stars. It also tracks the total stellar mass in the spheroid and the luminosity of the host core. The relation hints at negotiation between eater and home. When the hole feeds greedily, winds and jets throw temper back into the host, heating gas and sweeping dust from potential nurseries. Star formation slows, then resumes when the outflow quiets. The message is not one way. Gas infall during mergers, or inflows along cosmic filaments, can both starve and feast the black hole. The result is a feedback conversation written in light and in the ages of stars. Evidence for the monarchs is both theatrical and precise. At cosmological distances, quasars blaze with power too extravagant for stellar engines. Their spectral lines shift and broaden with motions of tens of thousands of kilometers per second. Reverberation mapping times the echo of continuum flickers in the broadline region, finding scales that place the mass in the millions to billions of suns. Closer by, megamasers orbit in thin circumnuclear disks that can be clocked with exquisite accuracy. The curves described by those tiny beacons are Keplerian, and the center holds a mass that no cluster can hide without revealing itself in collisions or light. In a few famous cases, the shadow of the hole is sketched by light, bent around it, a dark coin encircled by a lensed ring that matches the expected diameter. Feeding leaves weather. Relativistic jets launch from the polar regions of accretion disks that are threaded by magnetic fields. The fields tap the rotation of the disk and possibly the spin of the hole, then collar plasma into narrow beams. Those beams punch through the interstellar medium, inflate radio lobes, and seed galaxy clusters with cavities like bubbles frozen in glass. Winds flow from the disk surface and carry metals into the halo, where they mix with fresh accretion from intergalactic space. The temperature and entropy of cluster gas record these events in long memory. In one register, the hole is invisible. In another, it is the loudest voice in a million light-year choir. There is also the quiet of fasting. Many central black holes sit with little fuel and sip slowly. In these systems, low accretion rates create a radiatively inefficient flow that remains hot and puffy. The glow shifts to radio and hard X-rays, the disk thins to a whisper, and jets may dominate the energy budget. The hunger is never gone, only paused. A single star on a fatal orbit can wake the nucleus with a tidal disruption flare, a brief, splendid meal that brightens the galaxy and advertises the mass of the diner. Mass ranges carve out strange deserts and continents. Pair instability can unmake stars of certain sizes by blowing them to atoms without a remnant, leaving a gap in remnant masses. Supernova mechanisms stutter and create a divide between the heaviest neutron stars and the lightest black holes, though observations hint that nature is not always strict. Metallicity changes the map by altering stellar winds, and low metal progenitors bequeath heavier remnants. Dynamics in clusters reshuffles the deck through repeated mergers, building heavier black holes than single-star death would produce. The census is a palimpsest of stellar physics, gas dynamics, and chance encounters. The ladder rises toward a summit that has no crown, only continuing accumulation. Ultramassive black holes weigh tens of billions of suns and sit like silent anchors in the most massive galaxies. Their light is not proportionate to their authority, because many live in quiet phases. Their gravity settles disputes among stars and gas with finality. The galaxy around them carries the trace of ancient feasts in quenched star formation and in halos salted with metals. On the scale of cosmic history, these monarchs act as regulators, throttling the rate at which matter becomes new suns and planets. From embers to emperors, the sequence is both brutal and orderly. Deaths of massive stars stake the first claim, leaving behind compact engines that announce themselves with hard light and orbital clues. Crowds of stars and flows of gas conspire to assemble larger seeds. Galaxy mergers provide both food and companionship for central holes, and the unions ring space-time while enlarging the ruler. Feedback closes the loop, setting the pace of starbirth and the thermal state of the circumgalactic medium. The ladder is carved by gravity, furnished by matter, and climbed by time. The tail is not a procession of accidents. It is a design with room for chaos, a structure that channels noise into architecture. Black holes do not simply end stars. They elevate the remains into forces that shape cities of stars. A single collapsed core can, given patience and meals, become the quiet law at the center of 100 billion lives. The cosmos crowns its cities with the relics of death, and those crowns rule without face, without speech, with only the unyielding persuasion of curved space. The border begins as a definition and ends as a feeling. Far from the central mass, light cones stand upright like tidy tents pitched on a calm plain. Closer in, they lean. The future that once pointed in any useful direction now tilts inward. The tilting grows steeper until the cone narrows to a slit that lies almost flush with the surface of an invisible sphere. That sphere is not made of matter. It is a rule expressed as a place. Crossing it is not like stepping over a painted line. It is allowing every possible future to aim toward a single interior fate. The skin of no return is a null surface that edits causality without a sound. A hovering observer finds this region unforgiving. To remain fixed above the border, rockets must provide an acceleration that climbs without mercy as the radius shrinks. Instruments report that the required thrust tends toward infinity as the limit is approached. Sensors strapped to the hull measure a steady howl in the microwave darkness, an effect of acceleration itself causing a bath of particles to appear in the frame. What began as an effort to stay still becomes a contest with geometry that no engine can win for long. The nearer the hover, the fiercer the cost in fuel and heat. The lesson is not about engineering. It is about how tightly the metric is knotted. Clocks betray the setting even when they refuse to stop. A timepiece left far away ticks with faithful rhythm. A twin carried toward the border ticks slowly when judged from the safe distance. Photons that climb out of the potential well lose energy and drift to longer wavelengths. Red becomes crimson, then infrared, then a signal too faint to register on any finite detector. To the distant astronomer, the final approach of any beacon appears endless. The last moments are stretched into a vanishing tail of dimming light. The faller, in contrast, experiences a perfectly ordinary passage through the surface in finite proper time. Two narratives remain loyal to the same laws, each honest within its own frame, each describing a neighborhood that shares only a sliver of agreement. Not all orbits are equal in this district. There exists a radius where a photon can loop the object in a perfect circle, balanced on a razor of geometry. This unstable track is the photon sphere. A nudge inward, and the light dives. A nudge outward, and it escapes, bent into a new path. The presence of this sphere gives rise to the bright ring seen when light from behind the object is lensed around the mass and focused toward the observer. Larger than this ring, less crisp than a wire, is a glow from matter racing in the last lanes where stable circular orbits still exist. Inside a critical radius for ordinary matter, circular motion becomes a losing proposition. Paths kink inward, even when tangential momentum is high. The disk of inflowing gas knows this boundary, by the way. Its turbulence changes pitch, and its flickers adopt preferred rhythms. For a rotating spacetime, the borderland gains an extra layer. Outside the true surface of no return lies a region where standing still, relative to the far universe, is impossible. Frame dragging forces everything to swirl with the spin. The static limit marks the outer edge of this storm. Between that limit and the horizon, an object may yet escape if it keeps moving and finds the right trajectory. The region behaves like a wind tunnel where inertia itself is caught in a cyclone. Observers floating here but prudent with their engines can still climb away. Observers who insist on idling are carried inward despite their wishes. The geometry enforces motion as if it were a law of etiquette. The fluid of space near the border behaves as if a membrane covered the whole. This mental device, the stretched horizon, sits just above the true surface and carries properties that resemble the behavior of materials. It conducts, it resists. It has a finite surface gravity that defines a temperature and an entropy proportional to area, rather than to volume. In calculations, the membrane damps currents and radiates as though it were a physical sheet. No actual layer exists that a hand could touch, yet the fiction organizes the equations and gives engineers of thought a handle on the interface between outside and in. The skin that is not a skin becomes a useful tool for predicting jets, fields, and flows. Tidal forces write their signatures in how bodies deform. The rate at which gravity changes with distance can be gentle or brutal, depending on the mass of the central object. Near the event horizon of a giant black hole, tides can be mild enough that a crossing body might feel only a slow stretch. Near the horizon of a smaller remnant, the same crossing tears shapes into filaments, atoms into chains, and memory into static. What matters is not the absolute pull, but the gradient across a length. The effect is not drama for its own sake. It is a practical measure that tells which kinds of objects survive, approach long enough to leave an electromagnetic diary. The magnetized plasma, circling in this zone, performs an untidy ballet. Lines of magnetic field thread the gas like invisible wires. Shear winds them into tight coils until they snap and reconnect, releasing energy in bursts. Turbulence stirs the disk, transporting angular momentum outward and mass inward. Hot electrons and ions radiate across the spectrum. Polarization maps trace the swirl of fields and hint at the orientation of the spin. The borderland is both furnace and workshop, forging the signals that betray the presence of the invisible center. Every flare, every flicker, carries information about distances measured in units of the horizon size and timescales set by orbits that skim perilously close to the point of no reprieve. Lens effects make the neighborhood stranger. A bright knot in the disk can appear in multiple images as its light threads around the mass along different routes. Some paths skim the photon sphere and suffer long delays, emerging as echoes in time. The image of the disk folds over itself, creating bright crescents, thin arcs, and ghostly repeats. To an instrument with sufficient resolution, the borderland looks like a funhouse of optics carved by gravity rather than by glass. This distortion is not incidental. It sketches the metric directly. Measurement of the ring diameter and asymmetry encodes mass and spin. Deviations from expectation would whisper of exotic features in the field equations. Fidelity reassures that the simple parameters are enough. Inside the computational models that simulate this environment, coordinate choices reveal their personalities. Some coordinates misleadingly suggest that the horizon is a singularity when it is only a stubborn surface for those who insist on static frames. Others glide through the crossing with ease, tracking infall as if rowing on a current that quickens but does not break. The lesson is caution. The skin of no return is not a pathology of description. It is a real boundary in the causal structure that any honest set of coordinates must respect. The tidy map used far away must be replaced by a chart suited to rapids. Energy budgets here are negotiated by competing flows. Radiation pressure can choke infall. Magnetic stresses can accelerate it along preferred channels. Thick disks near high feeding rates puff up and shadow parts of themselves, changing which photons escape to tell the tale. Thin disks at modest feeding rates give off signature spectra with iron lines broadened by both speed and gravity. At the very lowest rates, the flow becomes feeble at radiating, and most of the heat rides inward rather than out. The state of the plasma at the borderland is therefore not a single mood, but a set of regimes, each with observable fingerprints. Even the idea of temperature grows subtle. A hovering detector reports a blaze that intensifies as the position nears the horizon, because the same photons that look ordinary locally are seen redshifted by distant eyes and blue-shifted for those clinging to the edge. The very definition of heat separates into what is measured in the local frame and what arrives at infinity. In that divide, arguments about entropy and information find their playground. The surface gravity that defines the ease with which a horizon accelerates returning light also sets a thermal scale. The border, quiet to the naive eye, turns out to be crowded with meanings. Practical navigation across this territory requires humility. Light used as a ruler bends back on itself. Radar ranging returns distorted echoes. Gyroscopes precess in patterns that signal the deep curvature of the field. Entry trajectories that were safe at larger radii now convert radial error into doom. The skill is in reading the geometry, rather than trusting Euclidean instincts. The safest path is often counterintuitive, threading a course that uses the swirl to gain altitude rather than fighting it head-on. No particle, no wave, no promise of technology defeats the fact that the border is final for outbound causation. That stark rule gives the skin of no return its eerie authority. Everything outside remains connected by messenger particles and fields that dilate, delay, and distort but still arrive. Everything inside is exiled from that conversation. The quiet enforcement of this separation is the deepest character of the boundary. It does not threaten, it does not shout. It simply redraws what it means for one event to influence another. The neighborhood around the horizon is therefore not empty decoration, but the decisive theater where nature informs on itself. In the glow of the last stable orbits, in the wrapping of light around a central silence, in the forced motion of frames near rotating throats, the laws of gravity reveal their most uncompromising face. The border does not negotiate. It teaches by example, setting conditions under which time and space trade roles, under which standing still ceases to be possible, under which the grammar of cause is edited line by line until only inward verbs remain. Tide is a quiet word for a brutal fact. Gravity does not pull evenly across a body. The side nearer the source feels a stronger tug, the far side a weaker one, and the difference goes to work like a patient artisan. On Earth, the oceans breathe in this rhythm, rising and falling with the moon's influence. Near a compact mass, the same principle leaves gentleness behind. The gradient of gravity becomes a sculptor with iron tools. Stretch along the line of fall, squeeze across it, repeat without mercy. The mathematical heart of this lies in how neighboring paths through space-time diverge. 2 points on a falling object follow geodesics that begin almost parallel and then curve apart at different rates, because the field is not the same for each. The geodesic deviation equation translates this into a second derivative of separation that is set by components of the spacetime curvature. These components assemble into the tidal tensor, a bookkeeping device that predicts strains a traveller would measure. It is a clean prescription that renders horror with elegance. The strains do not care about composition. They care about distance from the centre and the mass that sets the curvature. Scale is everything. A stellar mass black hole wraps so tightly that the tidal gradient near its horizon can exceed the strength of nuclei. An astronaut crossing that boundary would not notice a wall or a flash. The recognition would arrive as an unstoppable elongation along the falling direction and a pinching of ribs and ship and thoughts. The effect earns a grim nickname in textbooks, a reminder that the end product resembles a thread pulled long. For the truly gigantic residents of galactic cores, the story changes. Their horizons are large enough that the same astronaut could drift inward with no immediate discomfort. The fatal strains would come later, deeper, where the curvature finally explodes into dominance. Size buys time. It does not buy safety. Fragments do not remain inert once their cohesion fails. Molecular bonds snap and release their small energies into heat. Dust grains grind into plasma. The stretched material spreads into a thin stream that wraps around the whole like glowing wire. Differential velocities along the stream shear it into segments. Some portions lose enough energy to fall through the horizon, while others borrow a little speed and slip back outward on eccentric arcs. The returning debris is not a reprieve. Gravity catches it again and sends it back on a schedule. The rate at which this returning material rains down sets a light curve that traces a descending power law, a slow fading that tells observatories they have watched a life unweave. When the victim is a star, the drama earns a name. A tidal disruption event advertises the hidden diner. The stellar core is pulled apart and smeared into an accretion flow that heats to ultraviolet and soft X-ray temperatures. The spectrum bears the fingerprints of elements torn from deep inside, while the timing follows a cadence that theorists recognized long before the first alerts arrived. In some cases, a jet ignites and points briefly toward Earth, turning the event into a hard X-ray flare that flickers as the central engine settles into a new rate of feeding. In others, the energy is reprocessed by dust in the host, glowing in infrared for months. Each variant is a sentence written by the geometry, the star's structure, and the way the fragments encounter one another on their return. Closer than a star, planets and comets can meet the same arithmetic. In a crowded nucleus, long wandering bodies on unlucky tracks can fall into the zone where their own cohesion is trivial compared to the gradient of gravity across their diameters. Rock becomes vapor in a plume that briefly outshines entire constellations. Metal traces in the spectrum remind observers that worlds once circled a distant sun before a central darkness altered their fate. Smaller wrecks speak in brief whispers. Large ones sing with a longer tale. All of them draw the same diagram of a universe that respects the difference between near and far with implacable exactness. The traveller's clock keeps its stubborn honesty during this unwinding. Proper time along the falling world proceeds steadily. Muscles tense, alarms rise, materials enter regimes for which there were no tests on any human bench. Outside, the scene looks completely different. Photons trying to flee the deepening well leave later, redder, fainter. Signals smear into a last, lazy glow that stretches past the patience of instruments. The body that is being converted into thread and then into fog seems to pause and dim rather than to shatter. Two visions describe one reality. The disagreement is not a contradiction. It is what curved geometry demands when observers live in frames that cannot share more than light allows. Rotation changes the choreography. In a spinning spacetime, frame dragging compels matter to swirl and steals some of the free choice about direction. The stream from a disrupted star is not only stretched and squeezed but also torqued. Parts of it collide with themselves, as nodal precession shifts the orbital plane and incoming segments cross older paths. Shock fronts blossom where the stream meets itself and circularizes into a disk. These collisions are violent enough to radiate strongly and to carve spectral lines that encode the tilt and speed of the gas. The whirl does not slow the tide. It directs the fragments into patterns that tell an attentive eye how fast the central object turns. There is a quieter tidal story, written not in flares but in trajectories. In the gravitational playground of a galaxy, close passes by a massive compact object can peel stars from binary pairs, leaving one captured and the other thrown away at desperate speeds. The orphan hurtles into the halo as a hypervelocity star. Its path through the galaxy is a straightened echo of the near miss. The captured companion slowly tightens its orbit through interactions with other stars and gas, creeping toward a final spiral that ends with a flare or with a quieter gulp. Here the tide acts as both fork and knife, dividing and consuming with a single move. Deep inside, past the polite layers where orbits still have names, the tide becomes a summary, not a detail. The singularity waiting ahead is not a place, but a limit that crushes any extended object into shapes it cannot survive. In idealized models, there are cancellations and special cases. For certain spinning geometries, transverse directions may stretch rather than compress near the end, or the balance between forces may create strange, brief shelters where an object is distorted less than expected. These exceptions do not rescue. They decorate the inevitable. The basic fact remains that curvature grows until it defeats chemistry, then nuclear matter, then any hope of engineering a structure that keeps its identity. Even light feels a kind of tidal fate. Beams that begin parallel near the hole can converge or diverge under the focusing action of curvature. The Riccio-Dori equation records this in the language of expansion, shear, and vorticity. Focusing means intensity grows along certain paths. That is why hot spots on a disk can appear and vanish, as lensing alternately magnifies and dims them on their way to a distant detector. The tide of light is less visceral than the tide of flesh, yet it is the same geometry at work, turning gentle differences into decisive outcomes. The memory of a disruption lingers in its environment. Gas launched in winds carries metals from a star's belly into the circumgalactic medium. The hole's spin can change by small increments depending on whether disrupted debris arrives with or against the prevailing swirl. Stars that survive grazing encounters emerge with wounded envelopes and altered orbits, their future evolutions rewritten by a single pass. Even dark visitors like compact remnants or primordial lumps, if such exist, would leave nicks in the ledger of motion and heat. One act of tidal violence becomes a footnote in a larger story about how a galaxy grows old. The fear attached to these tides is not only about endings, it is about the intimacy with which the universe reads position. A separation of a few kilometers along a body becomes the difference between survival and ruin when the gradient is steep enough. The same precision governs everything else that matters at this scale. Timescales of seconds determine whether a stream self-intersects soon and circularizes, or misses and returns again. Angles of a few degrees set whether a jet from a newly formed disk points toward us or writes its fierce line elsewhere. What looks like chaos is precision obeyed in regions where precision hurts. To understand a tide here is to admit that space is not a passive emptiness. It is a medium with texture, and black holes give that texture its sharpest edges. The unspooling of a body is not a spectacle arranged for a distant audience. It is the inevitable outcome of neighboring geodesics in a field that has nothing personal to say. The language of curvature turns a person, a planet, a star, into grammar parts, stretching the sentence into a final clause and then into silence. From that silence, radiation escapes in disciplined forms, revealing what the body became as it crossed the last thresholds available to matter and light. The first dawn of galaxies arrives with a paradox smouldering at its center. In the young universe, when hydrogen still carried the chill of expansion and the earliest stars were newborn fires, some nuclei already housed black holes, weighing hundreds of millions of suns. The clock on the wall of cosmic history had hardly begun, yet these engines burned with the appetite of ancients. Their light crossed seas of neutral gas, carved tunnels in the fog, and announced monarchs that should not have had time to be born, let alone to rule. The puzzle is not whether gravity can make such rulers. It is how quickly the throne was built. Growth has a schedule when radiation pushes back on infalling gas. Feed a black hole near the Eddington rate, and its mass doubles on a timescale of several tens of millions of years. Stack enough doublings and a modest seed can, in principle, become a titan. The arithmetic turns delicate under the pressure of a short calendar. From the first star clusters to the appearance of billion solar mass holes, the universe offers only a few 100 million years. The margin for interruptions is nearly absent. Any period of fasting, any spin that raises radiative efficiency, any wind that carries fuel away, threatens the plan. The existence of early giants implies either seeds that began heavy or growth that cheated the conventional limits. One proposal sets the seed size high from the start. In certain neighborhoods of the infant cosmos, halos of dark matter gathered gas that could not cool by molecular hydrogen, because a background of ultraviolet light had already broken those molecules apart. Without efficient cooling, the cloud avoided fragmenting into a swarm of small suns. Instead, it collapsed nearly as one, forming a supermassive star that lived briefly and then fell through its own pressure into a black hole already weighing perhaps 100,000 suns. The conditions required are selective. Radiation must be strong enough to quench molecules. Metallicity must remain low so that dust does not carry the heat away, and the inflow must stay smooth. Yet the early universe provides pockets where such rules can be met. Massive seeds shorten the distance to emperors. Another path keeps the seed lighter but speeds the meal. Accretion flows can enter a regime where radiation is trapped by their own density and cannot easily escape. The disk puffs up, photons ride inward with the gas, and the effective efficiency drops. A lower efficiency means less light per unit mass swallowed, and the outward pressure that normally chokes inflow weakens. Feeding rates can exceed the classical limit for a time, without violating the accounting of energy, because the trapped radiation adds its weight to the infall. These so-called slim disks convert the luminous pressure into more growth. If such episodes recur often enough, a modest seed can race the clock to a staggering final mass. Spin participates in the conspiracy. A rapidly rotating black hole radiates more efficiently when matter spirals inward along orbits aligned with the spin, because the inner edge of the disk sits closer to the center and has more gravitational energy to release as light. High efficiency slows growth. Chaotic infall, where gas arrives from changing directions in discrete packets, can flip the spin, lower the long-term efficiency, and allow more of the inflow to become mass rather than light. Mergers of seeds with misaligned angular momenta further scramble spin history. The fastest-growing giants may be the ones that live through seasons of disorder. Stellar crowds add a third strategy. In the dense core of a young star cluster, repeated collisions can fuse the heaviest members into a single swollen star that collapses into an intermediate mass black hole. The surrounding cluster funnels more donors toward the center, and tidal captures build a moat of gas from disrupted stars. Although the process is messy and depends on chance alignments, the early universe had many such crowded rooms. The debris of collisions provides fuel on short timescales, and the new seed sits where the local gravity already tends to feed it. The landscape of the first galaxies makes all of these tactics more credible. Cold streams of gas, narrow and fast, flow along the dark matter skeleton into young halos. They bring unshocked fuel directly to the center, bypassing the delays of a hot atmosphere. Self-gravity in the newborn disks drives bars within bars, internal structures that torque gas and drain its angular momentum so that it spirals toward the nucleus. Each of these mechanisms helps create a persistent inward current. In such a kitchen, even a picky eater grows fat. Observations provide constraints and hints rather than a single instruction. Spectra of early luminous nuclei show broad lines from gas moving at extraordinary speeds, and the inferred masses sit at scales that make astronomical patience look insufficient. Host galaxies at those times appear compact and rich in gas. Dust appears sooner than expected, suggesting that supernovae and early stars built the ingredients for cooling and obscuration with surprising speed. Some active nuclei are deeply veiled, their light reprocessed into infrared. Concealed growth could be common, with black holes feeding in private, their signatures slipping out as warmth rather than as the bright knife edge of ultraviolet light. If much of the growth is hidden, the apparent paradox softens, because the census of visible giants would be a small fraction of the true population. Galaxy mergers in the young universe add quick, heavy meals. Halos are small and frequent, and their unions drive gas toward the center in floods. Each merger can also deliver another seed. Pairs of black holes form and begin to sink through dynamical friction, binding into binaries that harden and finally coalesce. The union produces a brief feast. The remnant often receives a kick from the anisotropy of emitted gravitational waves. If the kick is gentle, the black hole oscillates and resettles with fresh gas to swallow. If the kick is strong, it can displace the ruler or even eject it, leaving a vacancy that must be refilled by the next in line. The very existence of ejections means that the observed survivors are the lucky ones, which in turn implies a larger formation rate to account for losses. The early light has one more judge in the background: ionization of the universe. As the first stars and active nuclei ignite, they peel electrons from hydrogen, turning fog into clarity. If black holes contributed a large fraction of the photons that performed this work, then their number and activity must have been substantial. The timing and patchiness of reionization become indirect witnesses to the growth histories of invisible engines. Photons from accretion can travel farther than stellar ionizing light because their spectrum reaches higher energies, altering the topology of the reionized patches. The shape of that patchwork contains clues about who did the unmasking of the sky. On the theoretical bench, simulations chase the cascade from a halo's arrival to a seed's birth. The models fold in chemistry, turbulence, radiation transport, magnetic fields, and the granular infall of clumps. They produce virtual galaxies where gas streams gather in the center and form either starbursts or direct collapse candidates, depending on details of radiation and metallicity. They build star clusters that merge while their gas still births new members, transforming the core into a single heavy object in a few million years. They spin disks that fragment or that thicken into funnels that hide their own light. In these numerical worlds, seeds grow through a patchwork of modes. No single channel owns the story. A more radical idea posits that some black holes formed even earlier, from density fluctuations in the primordial plasma. If rare pockets were overdense enough at very high energies, they could have collapsed into black holes soon after the universe became transparent. Such primordial relics would begin with a head start measured not in millions but in billions of years. Their existence is tightly constrained by gravitational lensing statistics, by background radiation limits, and by the lack of observed evaporation signatures for the lighter members of the hypothetical family. Yet, a small population in certain mass ranges remains alluring. If any substantial fraction survived, the mystery of early giants could inherit part of its answer from the first microseconds of time. The puzzle of rapid growth is not a single question with a single key. It is a conversation among environment, chance, and limit. Massive seeds from direct collapse reduce the required number of E-foldings. Supercritical feeding in trapped radiation flows shortens the clock without violating conservation. Chaotic accretion moderates spin and lowers the tax of efficiency. Collisional clusters provide heavier starting points. Mergers contribute both mass and drama. Cold streams and gravitational torques deliver fuel with haste. Obscuration hides many of the steps from our telescopes, so the apparent miracle maybe only the visible tip. Taken together, these pieces sketch a universe that built its largest engines with a speed that seemed implausible until the data insisted. Fear in this context is admiration with a sharper edge. The early universe did not hesitate. It learned to bend gas into funnels, to concentrate stars until they broke their own symmetry, to invent shortcuts whenever a limit loomed. The giants that appear against the backdrop of first light are not mistakes. They are announcements that gravity and radiation, when given the raw simplicity of hydrogen and dark matter, can write epics faster than anyone expected. The engines at those young centers did not wait for permission. They took the first dawn as an invitation and grew until their light rearranged the morning. A quasar lights the dark like a verdict. Across distances that swallow constellations whole, a point pricks the night with a brightness greater than the combined glow of 1,000,000,000,000 stars. The engine is not a flame in free air. It is a banquet at the lip of gravity, where gas spirals toward a black hole and leaves a fraction of its rest mass behind as light. The efficiency is indecent compared with any furnace that burns by chemistry or fusion. Each gram falling inward can release energy enough to move worlds. The signature of that appetite is written across the spectrum, from radio murmur to keening X-ray, a continuous hymn to hunger. The shape of that hymn carries clues. In the optical and ultraviolet, broad emission lines balloon outward from gas moving at thousands of kilometers per second. The same continuum flickers on timescales of days to months, a tremor produced by turbulence in the inner disk or by the slow pivot of magnetic fields threading the flow. The broad line region breathes with the central glow. A flare in the continuum reaches out, and a delayed echo returns as the lines brighten. Measuring the lag between the flash and the reply gives a radius. Measuring the velocity width of the lines gives a gravitational speed. Multiply the two in the language of virial motion and a mass emerges. The quasar becomes a scale, the light itself a weight. Closer in, the spectrum is sculpted by iron and oxygen, by carbon and nitrogen, elements cooked in earlier generations of stars and fed back to the nucleus. Their presence at great distance and early cosmic time hints that enrichment moves quickly when galaxies are young. The iron lines in X-rays bend and broaden, their shapes curved by Doppler motion and by gravitational redshift near the inner rim of the accretion disk. From those shapes, the radius of the last stable orbit can be inferred, and with it the spin of the black hole. A black hole that spins quickly allows the disk to reach in closer, increasing both radiative efficiency and the temperature of the inner light. The quasar sings not only of mass, but of rotation. Orientation acts like a mask. A circumnuclear structure of dust and molecular gas wraps the bright center. View the system face on, and the glare is raw. View it from the side, and the dust sifts the light into infrared, re-emitting the heat it could not bear to transmit. This geometry explains why some active nuclei blaze in ultraviolet, while others glow in warmth. The unification does not erase variety. Winds rise from the disk and stamp absorption troughs across the ultraviolet spectrum, sometimes so broad that entire swathes of light are bitten away. These broad absorption line quasars are engines blowing on their own fires, exhaling at thousands of kilometers per second, pushing on the gas that once intended to feed them. The power of a quasar is measured not only by its glare, but by its will to reorder its surroundings. Jets launch along magnetic axes that thread the inner disk, and perhaps tap the rotational energy of the hole itself. The beams stab through the interstellar medium and inflate lobes larger than their host galaxies. Their radio light maps cavities in clusters and paints bubbles in hot gas, as if someone had blown imperfections into molten glass. Closer to the engine, wines with broad, solid angles carry momentum that rattles the bulge and scours cold clouds. When the thrust is high enough, star formation slows or halts. The result is a dialogue between Eta and City. A galaxy that feeds too freely raises a monarch who speaks back in jets and gales, turning a feast into a lesson. The intergalactic medium becomes a parchment for that light to write upon, Along the line of sight from a quasar to the telescope, clouds and filaments of hydrogen scratch narrow absorption lines into the spectrum. Each line marks a redshift and a density, tracing the cosmic web-like pencil on rice paper. Near the quasar, the fog is thinner. Ionizing photons from the engine carve a proximity zone in the forest of lines, a transparent bubble that announces the reach of radiation. At early times when the universe still favoured neutrality, such zones were markers of progress in the long unmasking of hydrogen. Quasars became beacons, announcing not only their own ferocity, but the state of the sea through which their light had travelled. Variability is a signature as distinctive as a fingerprint. In some, the continuum flickers like a candle in a draught. In others, the changes are more dramatic. A changing-look quasar can dim until its broad lines fade, then brighten and call them back as if recalling a choir. The transition speaks of fuel supply and of how the inner disk reorganizes itself when inflow is throttled or resumed. Rarely, nearly periodic dips or hums suggest the gravitational pull of a companion black hole in a tight orbit, modulating the flow as if turning a cosmic valve. While such cases remain a minority, they turn attention to the possibility that many bright engines are midway through a merger's endgame. Gravitation can serve as a magnifying glass for the feast. If a galaxy lies along the path to a distant quasar, its mass bends the light into multiple images or long arcs. In each image, the quasar flickers with its own schedule. Microlenses within the lensing galaxy, built from the stars themselves, add subtler tremors as their small gravity wells sweep across the quasar's face. The differential magnification encodes the size of the emitting regions, with the tiny X-ray corona amplifying more readily than the larger optical disk. The distant eater becomes a laboratory whose rooms can be measured despite the impossibility of approach. Quasar color tells on the flow regime. Thin disks at moderate rates yield a blue ultraviolet slope and a thermal bump in the optical. Higher accretion rates bury the inner light under a thicker atmosphere, shifting energy to lower frequencies. At very low rates, the flow turns radiatively inefficient, and the spectrum hardens, with jets shouldering more of the power. The ratio of X-rays to ultraviolet, the strength of certain lines, the shape of the infrared tail, all combine into a set of diagnostics that place a quasar on a map with axes of mass and feeding rate. On that map, motion over years to decades can be read as changes in diet or in geometry. The host galaxy does not always yield the stage willingly. Dust lanes cut across starlight, bars twist the inner disk, and tidal tails hang like torn ribbon after encounters. High-resolution imaging reveals faint structures that betray recent unions. In those systems, the quasar often sits where streams of gas converge, as if a city's roads had been designed to deliver the food to a single door. Yet equally luminous engines can reside in galaxies that show no fresh wounds, implying that slow secular processes can also deliver a steady flow. Bars within bars channel gas inward. Spiral density waves stir clouds into migration. Internal dynamics can replace the drama of mergers with the patience of drift. As bright as they are, quasars hide as well as reveal. A thick curtain of gas can cloak the engine in X-rays and optical light while allowing infrared to escape. Surveys that filter by color, by radio emission, or by hard X-ray reveal different populations that overlap only partly. The census is always incomplete. Correcting for the unseen changes the total energy budget of growth. It also softens conflicts with the rapid appearance of large masses, because hidden feeding episodes extend the time and the duty cycle beyond what the luminous subset suggests. The most distant quasars perform a final service. Their light has been stretched by cosmic expansion until the signatures of hydrogen absorption fall into the near-infrared. The shape of the damping wing on the red side of the strongest line contains the handprint of neutral gas between the source and the observer. Those handprints imply a sky still learning to let light through, a sky where each quasar's ionization bubble is a lantern in fog. That lantern tells how many photons the engine emitted and for how long. It also tells how the fog itself was thinning under the combined efforts of stars and black holes. To call these lighthouses is not to flatter. A lighthouse warns of rocks and guides ships, but a quasar does more. It changes the shoreline as it shines. The winds and jets carve and heat. The radiation strips electrons and moves metals. The engine eats and publishes both a diary and a weather report. In the glowing arcs of lensing, in the echoes of reverberation, in the skewed iron lines, in the forest of hydrogen scratches, in the sudden silences and returns of changing look states, the story of appetite is told with a precision that leaves little room for myth. The terror belongs to the knowledge that such power comes from a rule as simple as fall inward and release what you can. The beauty belongs to the clarity with which nature lets that rule be seen across the largest distances a universe can offer. Two dark bodies circle without light, yet the universe hears them. Their gravity is their only language, and it is enough. Each orbit stirs space-time as a spoon stirs water, raising a faint spiral of ripples that stream away at the speed of light. As the pair draws closer, the ripples grow sharper and faster. The pattern is a chirp, a rising note that ends in a sudden silence, that is not silence at all, only the stillness of a single remnant catching its breath. No glow announces the event, unless nearby gas is unlucky enough to be dragged into motion. The collision is private, yet the fabric of space carries news of it across billions of light years. The signal begins long before the crash. Far apart, the two black holes trace slow ellipses and radiate very little. Quadrupole radiation steals a whisper of energy, and the orbit shrinks. Each cycle returns the bodies closer together. Frequencies climb, amplitudes grow, and the waveform tightens like a coiled spring. In the final seconds, the motion reaches a frenzy measured in hundreds of orbits per second for stellar mass pairs. The chirp ends at the contact of horizons, and the newborn remnant rings like a struck bell. That ringdown is not a metaphor. The geometry supports discrete quasi-normal modes, tones whose pitch depends only on the mass and spin of the final hole. Here more than one, and the identity of the remnant can be tested with precision. The instruments that listen are interferometers that measure distance with light and patience. Laser beams travel in long perpendicular arms, bounce between mirrors, and recombine to reveal changes in length that are smaller than a proton. A passing wave stretches one arm while squeezing the other, then reverses. The pattern of brightness at the output port flickers in sympathy. A single observatory hears a strain with poor knowledge of where it came from. A network hears a direction because the wave arrives at slightly different times and with different polarizations at each site. Triangulation paints a swath on the sky, sometimes small enough to guide telescopes, more often wide but still informative. No one listens blindly. The data are searched with families of predicted waveforms that depend on masses, spins, and orbital shapes. This matched filtering raises a hand whenever the noise reproduces a pattern too well to be chance. A candidate then faces vetting by independent pipelines and cross-checks between instruments. Surviving events become points in a growing catalogue. Each point carries posterior distributions for the masses, spins, distance, and inclination. Each pair adds to a population that begins to speak in statistics rather than in singularities. The first clear lessons surprised as much as they satisfied. Stellar mass black hole binaries exist in numbers that make the night busy with unlit meetings. Many members are heavier than expected from familiar X-ray binaries, hinting at origins in low metallicity environments where winds are weak and stars die with more of their birth mass intact. Spins are often modest or misaligned with the orbital axis, a hint that at least some pairs assembled in dense clusters rather than in quiet binary evolution. There are gaps in the mass spectrum where stellar physics predicts unstable progenitors and complete disruption, and there are intruders at the edges of those gaps that challenge the neatness of the rules. The sky has always disliked clean borders. Some pairs carry eccentricity into the observational band. Circularization by gravitational radiation is efficient, so noticeable eccentricity near merger implies a recent dynamic encounter or a capture rather than long domestic evolution. Other pairs show signs of spin precession, a slow wobble that modulates the waveform and reveals that the axes are not neatly aligned. Each of these features is a clue to birthplaces. A quiet field binary tends toward alignment. A cluster with chaotic encounters does not ask for order. The finale leaves an imprint on the host. Asymmetric emission of waves during the last orbits, and ring down gives the remnant a recoil. The kick can reach thousands of kilometers per second in rare cases, when spins are large and arranged unfavorably. Typical kicks are smaller, but still potent. In galaxies with shallow central wells, a large recoil can displace the ruler for millions of years or eject it entirely. Oscillating remnants carve cores in stellar distributions, and ejected holes roam with small entourages of bound stars. These consequences are not easily seen, yet they are real signatures written into the future of a merger. Silence is not complete, even when no photons join the celebration. The merger bathes its surroundings in changing tides. If the pair lives in a disk of gas, torques can carve cavities, streams can feed the minidisks around each member, and shocks can launch flickers that may precede or follow the gravitational wave event. The reliable messenger remains the wave itself, because gas is not required. Gravity writes its own dispatches without needing assistance from plasma. At much lower frequencies, supermassive pairs conduct a slower symphony. Their orbits last years to centuries, and their waves are measured not with lasers but with clocks built from pulsars. Millisecond pulsars blaze with radio pulses, so regular that deviations at the level of tens of nanoseconds reveal the passage of a wave that swells an entire arm of the galaxy. A set of such clocks scattered across the sky forms a timing array. Correlated wanderings in their arrival times signal a background made by many supermassive binaries murmuring at once. The hellos and goodbyes of merging galaxies, repeated across cosmic time, add into a hum that fills the nanohertz band. Emerging evidence for that hum says that the universe is busy at the centers of big galaxies, and that the last parsec problem, the fear that binaries stall before gravitational radiation takes over, is often solved by interactions with stars and gas. Between the bands sits a future listener. A space-based interferometer will fly a triangle of spacecraft millions of kilometers apart, sensitive to waves that take hours to cross the instrument. That territory belongs to intermediate mass black hole mergers, to supermassive black hole inspirals far before their final plunge, and to extreme mass ratio inspirals, where a stellar mass object traces intricate loops near a giant for thousands of cycles. The last case is a unique gift. Each loop samples a different patch of the geometry, and the waveform becomes a map of the space-time near the horizon. With patience, the multipolar structure of the field can be measured and compared to the simple expectations for a clean black hole. Deviations would hint at hair that the classic no-hair statement forbids, or at new physics in how gravity behaves. Every detected merger is a test of the theory that predicted it. The rise and fall of the chirp follow post-Newtonian expansions when the bodies are far apart, then the numerical solutions of Einstein's equations when the horizons flirt, then the linear perturbations for the ringdown. Agreement across these stages is a deep check of the law. The ringdown in particular offers a clean measurement of the remnant's mass and spin from its frequencies and decay times. Comparing those to the numbers predicted from the inspiral alone becomes a consistency test. So far, the bill is paid with exemplary precision. The language of curvature, written a century ago, holds in the most violent places we can observe. Even the absence of light can teach. When a binary of black holes merges without any electromagnetic counterpart, the timing confirms that gravity's messenger travels at the same speed as light within tight bounds, because any difference would compound across cosmological distances and split arrivals by measurable amounts when a partner signal exists. When a neutron star participates, light and gravity arrive together within moments, a separate lesson that validates the universal speed in a different regime. The chorus of events we have now measured does not show dispersive effects for gravitational waves, and does not show extra polarizations beyond the two predicted by general relativity. Constraints on alternatives narrow each year as catalogues grow. The faintest feature may be the most haunting. A gravitational wave leaves behind a permanent change in separation between distant free masses, a memory written into space-time after the wave passes. Detecting this memory requires exquisite control of noise and long baselines, but its presence is a fundamental aspect of the theory. In principle, the memory from many mergers adds into a slow drift that timing arrays and future interferometers might catch. The universe keeps a record of violence, not only in stories of light and heat, but in the quiet repositioning of rulers. Population studies turn single thrills into demographics. The distribution of chirp masses tells of progenitor metallicities and star formation histories. The redshift distribution reveals the cosmic time dependence of binary formation channels, the relative rates of black hole pairs, neutron star pairs, and mixed systems track the fortunes of different stellar lives. Hierarchical mergers, where a remnant merges again within a cluster, build up higher masses and distinctive spin distributions. Each catalogue update refines these pictures, turning guesses into plots that tighten with every new voice added to the archive. Fear is a reasonable companion when listening to this music. The signals are reminders that invisibility does not mean innocence. Collisions of dark horizons repeat across the sky, indifferent to witness, unhurried by the presence or absence of gas and light. Yet there is calm in the precision. The waves follow equations that do not falter, and those equations return the favor by allowing us to weigh, time, and place events that happen farther away than any fire we can see. The giants merge in silence, and the silence speaks. The cosmos rings, and its bells are made of distance itself. The question arrives like a quiet verdict. When matter falls into a black hole, does the ledger of its details vanish, or does the universe keep books that no ordinary eye can read? Information is a shy word for something severe. It means the distinctions that once made a thing itself, positions and spins, phases and correlations, the embroidery of a star or a notebook or a cloud of ions. Classical gravity offers no comfort. The exterior settles into a featureless geometry with only mass, spin, and charge. The interior ends in a place where known laws lose their voice. The narrative suggests that individuality is erased. Quantum theory disagrees with erasure. In that disagreement lies a modern riddle. A quiet glow complicates the picture. In the 1,970 seconds, a calculation showed that a black hole set inside a quantum field does not sit in perfect night. Space-time curvature near the horizon makes the vacuum restless. Pairs of excitations that would normally annihilate are pried apart by the geometry. One partner escapes to infinity with a spectrum that resembles heat. The other pays the debt by carrying negative energy into the hole. The object shrinks by the smallest increments, and its temperature rises as it loses mass. The endpoint of an isolated small black hole is not a permanent monument. It is evaporation and possible disappearance. Thermal light is forgetful. It carries energy and nothing more than what temperature and area announce. If a black hole evaporates to a bath of featureless quanta, the map from initial state to final state cannot be one-to-one. That would violate the unitarity that underpins quantum mechanics. A theory that gives precise probabilities for outcomes cannot allow many distinct pasts to merge into a single future without some hidden record. The paradox tightens as one imagines feeding a hole bits of structure and waiting longer than comfort allows. Does the outgoing radiation ever reveal a trace of those inputs? An optimistic path sketches a curve. In the early stages of evaporation, the outgoing radiation behaves like noise. The entanglement entropy between the radiation and what remains inside increases. At a certain time, called the page time, the curve should crest. After that crest, more information should flow out than remains within. The final state would then carry the full story, encoded in delicate correlations among the quanta. This picture reconciles evaporation with unitarity. It demands a mechanism by which the radiation can carry structured entanglement, while the horizon still looks smooth to an infalling witness. There is trouble at the edge. If the outgoing quanta are entangled with partners behind the horizon, as the usual local description implies, they cannot also be entangled with earlier radiation that departed to infinity. Quantum monogamy forbids one system from sharing perfect entanglement with two distinct others. Either the bond across the horizon breaks, or the bond to earlier radiation never forms. Breaking the bond across the horizon turns the vacuum there into an excited state. That excited state reads like a wall of quanta to the traveller who falls through. The image is a firewall, a fire where there should be calm. The suggestion violates a cherished expectation that nothing special greets the crossing of a large black hole. Alternatives avoid flame while preserving bookkeeping. One proposal says that the horizon is not a place where degrees of freedom vanish. It is an interface carrying intricate structure, sometimes described as soft hair, a phrase that refers to low-energy excitations tied to symmetries of the gravitational field. If infalling matter imprints subtle patterns on the horizon, then evaporation could release those patterns in slow time. The details would be faint, yet complete. Another proposal elevates complementarity to a principle. It says that no single observer can see both a smooth horizon and the exact duplication of information outside. The world grants each perspective a consistent story, but it forbids any combination that would expose a contradiction. There is a grander frame in which the paradox looks like a signal rather than a crisis. Holography trades a problem of gravity in a space-time for a problem in a lower dimensional theory without gravity. In that dictionary, evolution is unitary by construction. The black hole is a hot lump in the higher dimensions. The dual is a thermal state in a quantum many-body system. No information is lost because the dual description keeps perfect track. The challenge becomes explaining how the bulk picture reproduces the page curve and the late recovery of structure. Recent work points to quantum extremal surfaces and islands that contribute to the entropy of radiation. In that accounting, after the page time, the radiation shares a non-trivial region with the interior. Entropy then falls as if the interior itself has become part of what the distant observer owns. The page curve appears without breaking the smooth horizon in the local sense. Scrambling adds a character trait to the black hole. A small input tossed into the throat becomes thoroughly mixed with the rest of the degrees of freedom in a time that scales with the logarithm of the entropy. This is the speed limit of chaos. The Hayden-Preskill thought experiment then imagines an old black hole that has been radiating longer than its page time. After the scrambling time, the information of a new message is hidden among the black hole's bits. Radiation emitted afterward contains that message in principle. A clever decoder with access to the early radiation and the newly emitted quanta could reconstruct it without waiting for the final dribbles of evaporation. The task is hopelessly difficult in practice, yet soothing in principle. The universe does not destroy the whisper, it hides it in a cryptogram. No cloning reinforces the subtleties. A perfect copy of an unknown quantum state cannot be made. If information escapes in radiation, it must be transferred rather than duplicated. That means the interior description and the exterior reconstruction cannot both be complete from one vantage point. Complementarity again answers. The infaller experiences a smooth passage and never meets a duplicate of the message. The patient observer outside collects a long series of correlations and builds the message from them. There is no experiment that lets a single observer compare notes from both sides. The paradox retreats into a domain without operational contradiction. Constraints from gravity itself join the dialogue. The black hole has a finite entropy proportional to the area of its horizon. That suggests a countable set of microstates. Evaporation can then be understood as a transition among those microstates, with emission governed by a unitary S matrix, a promise that the full scattering process preserves information. The difficult part is identifying the microstates in a theory without appeal to an abstract dual. String theory in certain cases enumerates states that match the area law. Quantum error correction appears as a theme in the duality, where bulk regions are encoded redundantly in boundary degrees of freedom. This redundancy might explain how interior data are reconstructed from fragments of radiation without ever cloning them. Memory effects provide an additional hint. A burst of gravitational waves can leave a permanent change in the relative positions of distant objects. This classical memory has a cousin in the long wavelength excitations that accompany radiative processes. If horizons register those soft modes, the final radiation could carry tags that balance the account. In that picture, what seemed like featureless heat hides a ledger of tiny adjustments that, in aggregate, spell the story of what fell. No single idea commands the field. Firewalls bring clarity and pain. Soft hair offers a granularity that comforts, and yet may be too gentle. Complementarity respects observers and forbids impossible comparisons. Holography enforces unitarity and gives exact page curves in toy universes that resemble laboratories for gravity. Quantum extremal surfaces and islands translate the page narrative into geometry, scrambling schedules when information becomes accessible. Error correction promises that delicate stories can be preserved in robust codes. Each element describes a facet of a vault that was once thought to be simple darkness. There is a moral that sidesteps personalities and metaphors. The question is not whether the universe keeps secrets. It is how it allows different witnesses to hold consistent yet incomplete truths. For the falling traveller, the horizon is gentle. For the far archivist, the horizon is loud, with patterns that are almost impossible to pass. No paradox arises unless one demands a viewpoint that nature does not grant. The fabric itself insists on a separation of perspectives, and within that separation, the books balance. The fear that information perishes gives way to a subtler anxiety. Retrieval is possible, yet unimaginably hard. The path from omission to meaning is tangled by chaos, diluted by distance, and encrypted by codes that no finite intelligence can break in practical time. The cosmos appears to honor its own rules, without compromising the serenity of horizons. It does not forget. It does not share easily. A black hole is then less a shredder and more a safe, one that leaks its contents back to the world in a drizzle of quanta arranged with impossible care. The secret of what falls in is that nothing fundamental is lost. What is lost is the hope of an easy story. The edge of a black hole used to feel simple. Smooth crossing, quiet vacuum, heat far away that no traveller would notice at the gate. Then quantum accounting raised its hand and demanded more care. What happens at the brink depends on which principle one refuses to surrender. The horizon has become a courtroom where unitarity, locality, and the equivalence principle present competing affidavits. Each proposal saves one virtue by bruising another. Each paints a new face on a surface that was once a pure rule. One vision sets a wall of quanta at the threshold. If outgoing radiation must carry detailed correlations to preserve unitarity, it cannot stay perfectly entangled with partners that fell inside. The bond across the brink breaks. The local vacuum becomes excited. An infalling witness meets a bath of high-energy particles where calm should reign. The firewall is brutally honest about bookkeeping. It keeps information safe by sacrificing the promise that a large black hole welcomes a crossing without drama. The cost is a wound to the equivalence principle at the place where that principle usually feels most secure. A very different picture arrives from string theory. Replace the interior with structure that fills the would-be volume. The fuzzball proposal says that each microstate of the whole corresponds to a horizon-sized tangle of strings and brains. No empty region, no classical singularity, just a vast complexity whose average resembles the familiar geometry. Radiation then can be detailed from the start because the surface itself carries structure that imprints the outgoing quanta. Smoothness gives way to richness. The price is high. The tidy, classical picture of a uniform horizon evaporates, and the simplicity of no hair is replaced by an encyclopedia written in Planck-scale ink. Another approach keeps a softer face. Soft hair refers to a halo of low-energy excitations attached to long-range symmetries of the field. These modes are not violent. They subtly register the history of what fell in, and later leak that record during evaporation. In this telling, the horizon remains kind to the traveller while still whispering information outward. The risk is sufficiency. Can such delicate tags encode the full detail of a collapsing star? Advocates argue yes, in principle. Skeptics worry that the capacity is too modest and that the dynamics of retrieval is hazy. A bridge idea offers non-locality without spectacle. Black hole complementarity grants different observers different but consistent narratives. The exterior description treats information as encoded in a stretched screen just outside the horizon, from which Hawking quanta depart with hidden correlations. The interior description grants a smooth passage without any visible copy of the data outside. No single observer can test both at once, so contradictions cannot be exposed. The principle rescues unitarity and calm by paying with strict limits on what comparison's nature allows. The discomfort lies in the hint that locality is only approximate, and that the world curates experience by censoring impossible experiments. Some proposals redraw the geometry rather than merely annotating it. A gravastar replaces the interior with an exotic phase of spacetime, a bubble where pressure and vacuum energy mimic the external field, while forbidding a horizon in the conventional sense. Regular black hole models thread the core with a patch of de Sitter-like material that stops curvature from diverging. Loop quantum gravity sketches a Planck star, a tiny core where quantum discreteness halts collapse and later rebounds, releasing what fell in after aeons. These cures keep the equivalence principle healthy and avoid singularities, but they bend classical energy conditions and introduce new states of matter that lack independent evidence. They also invite the question of how to hide the rebound from a distant observer who sees only slow red drifts. A more audacious conjecture links wormholes to entanglement. If two systems share a perfect quantum bond, perhaps a non-traversable geometric tunnel relates them. Then parts of the Hawking radiation already emitted might be connected to what remains inside via such threads. The interior could be reconstructed from the exterior without any clone appearing. The insight charms by elegance. It also stretches intuition about locality and builds bridges that cannot carry a traveller, yet still influence how information is accounted. Accept the link, and many puzzles soften. Reject it, and the burden returns to the raw edge where quanta depart. Islands describe the entropy book in geometry. After a long time, the minimal surface that computes the entropy of radiation jumps to include a patch just inside the would-be horizon. The outside observer then counts that interior region as part of what has already left. This reproduces the expected late decline of entropy without flame or fuzz in the local language. The magic lives in extremal surfaces and quantum corrections that blend bulk and boundary degrees of freedom. The penalty is conceptual strain. A region that an infaller would insist is inside becomes owned by the exterior accountant. The map distinguishes perspectives with exquisite precision and forbids any test that tries to hold both at once. Nonviolent non-locality takes a pragmatic stance. Let subtle correlations stretch across horizon-sized distances without creating hard shocks. Let effective field theory fail gently at scales where gravity compacts information. Then late radiation carries the needed detail, because the interior and the near exterior are not fully separate quantum rooms. The wager is that nature tolerates a thin layer of non-local influence that never rises to the level of a measurable violation for any realistic probe. This rescues unitarity and calm by admitting a modest reach beyond conventional locality. Corpuscular pictures attempt to demystify the geometry by counting quanta. In one story, the whole is a Bose condensate of soft gravitons, with evaporation as the slow depletion of that condensate. The horizon is then a collective state that can fluctuate and scramble with ferocious speed. Radiation can carry structure because the condensate is not perfectly uniform. The lure here is intuition. The risk is precision. Without a full theory that reproduces every detail of the classical limit and its quantum corrections, the picture remains metaphor that gestures toward a mechanism. These visions invite observational wagers. If structure sits near the would-be horizon, the merger of compact objects might leave late-time echoes in the ringdown as waves reflect from that structure. If the interior is stiff, rather than empty, tidal responses could differ subtly from the predictions for a classical whole, producing tiny but in principle measurable love numbers where theory demands nearly zero. If the surface emits deviations from a pure thermal spectrum, correlations in the quanta could carry imprints of the microstate and alter high-energy tails. If no horizon forms at all in some models, accretion should look different, perhaps with trapped heat or with luminous surfaces where none should exist. The discipline of listening keeps these speculations from becoming unchecked fantasies. Precision outcomes teach humility. Shadows measured against expectations match within current error bars. Ringdowns align with the quasi-normal modes of clean geometry. Spectra and timing from accretion flows trace orbits and redshifts that honor the simple theory. These agreements do not end the debate. They set bounds. Soft hair must be soft indeed. Fuzz must average to geometry on the scales probed so far. Fire must hide, if it exists at all, for large holes. Exotic interiors must mimic classical gravity with unnerving accuracy, except where quantum numbers whisper. At stake are familiar loyalties. Keep the promise that no traveller notices the crossing, and one risks losing unitarity unless hidden channels carry correlations with grace. Keep unitarity with iron will, and one risks scarring the horizon into a furnace that contradicts decades of faith in the equivalence principle. Keep locality as a sacred rule, and one must accept that the page curve refuses to bend, that the radiation remains featureless, and that the theory blinks. Release locality a little, and the books may balance. Each choice is a wager on which rule is more deeply true and which is only a reliable approximation. There is also the quiet question of taste. Clean horizons honor the human love of simplicity. Fuzzballs and hair honor the human love of detail. Firewalls are dramatic but stern. Holography offers perfection at the cost of moving the computation to a boundary theory where gravity never lived. Regular interiors restore calm while asking for materials yet unseen. Islands make entropy a cartographer's game. No vote settles these until either a principle prevails with new proof or a measurement breaks a tie. The horizon was once a geometric boundary that edited causality without fuss. Now it houses the most intense argument in fundamental physics. The debate is not noise. It is the sound of a field testing its loyalties. To keep the universe honest, something must give. Whether it is locality in its strictest form, or the exact serenity of the crossing, or the notion that gravity can be fully classical at large scales, will be decided by a blend of thought and listening. If the surface is a screen, a seam, a thicket, or a door into a phase we have not named, the choice will carry a bill. The price will be a cherished principle paid in small coins. The reward will be a story that keeps every ledger in balance. The universe keeps several kinds of ears. Some are made of mirrors and cold silicon. Some are built from baselines as wide as Earth. Some are rulers of light folded into triangles that float in vacuum. Each listens for a different accent of gravity, a different register of the same deep instrument. None can touch the thing itself. All of them learn its outline by the way it composes space and time around it. At radio wavelengths, the trick is to turn a planet into a lens. Very long baseline interferometry links antennas scattered across continents. The wavefront from a distant source reaches each dish with a slight delay, and atomic clocks fix those delays with arrogant precision. Add the signals carefully and the array behaves like a telescope with the diameter of Earth. Sharpen the focus to millimeter light, and the signal begins to sketch brightness on scales of a few times the event horizon. There the glow of turbulent plasma frames, a darkness that is not a surface, but a failure of escape. The shape of that ring and the emptiness inside give mass and distance in a direct way. Closure phases extracted from triangles of baselines resist atmospheric noise and let the image settle into a crescent, bent by lensing and by motion. Polarization betrays the direction of magnetic fields near the furnace. Faraday rotation counts the electrons in the path and estimates the depth of the cloak in front of the engine. X-rays speak closer to the heat. Disks that settle into thin sheets at moderate feeding rates radiate a spectrum that peaks in soft X-rays for stellar mass engines and in ultraviolet for supermassive ones. A compact corona of hot electrons Comptonizes those photons and sprinkles a hard X-ray tail on the spectrum. Some of that hard light rains back upon the disk and carves a set of reflection features. Chief among them is the iron K line, dragged wide and skewed by Doppler motion and by gravity. Fit the line with care, and the innermost stable circular orbit reveals itself. That orbit depends on spin. A line that stretches farther redward hints that the disk reaches deeper and that the hole turns fast. The corona itself answers questions through timing. Small flares in the continuum precede echoes in the reflected light by milliseconds to minutes. Those lags measure altitude above the disk and the size of the inner region. The combination of spectrum and echo is a ruler that reads in gravities rather than in centimeters. Timing alone is its own discipline. Quasi-periodic oscillations appear as faint hums in the power spectra of X-ray light curves. Their favored frequencies scale with mass and track the dynamics near the rim where orbits begin to fail. In some systems, twin peaks drift together as the accretion flow rearranges. Models assign these notes to nodal and periastron precession or to discoseismic waves. The instrument is messy yet musical. The hums test ideas about how strong gravity modulates motion when turbulence tries to wash the signal away. Elsewhere in the spectrum, infrared eyes watch hot dust pulse to the beat of the engine. When the nucleus brightens, the torus surrounding it warms and glows a little later. The delay measures distance in light days. Optical spectrographs monitor the breathing of the broad line region. A flicker in the continuum stirs the gas, and a wider mouth of light answers with delay. The lag and the linwidth together weigh the central mass through a simple virial idea. The lines remember past months and years, so the mass estimate emerges from patience rather than from a single snapshot. At longer radio wavelengths, jets reveal their architecture as knots slide outward and slow or speed in response to pressure changes and shocks. Very long baselines resolve the spine and the sheath. Polarization maps the twist of fields that help collimate the flow. Gravitational wave interferometers listen for the music that light cannot carry. On Earth, the arms are kilometers long, and the mirrors float on suspensions that mimic freefall. Laser beams chase one another between the end stations and recombine at a photodiode that stares at darkness. A passing wave disturbs the balance, and the darkness flickers. From the pattern of that flicker, one recovers masses and spins and distances. The ring down after a merger is a set of tones whose frequencies and decay times depend only on the remnant. Fit those tones, and the identity of the geometry is confirmed to numbing precision. Expanding catalogues let the population speak. They reveal places where stellar life, metallicity, and dynamics conspire to assemble pairs that choose to meet within the lifetime of the universe. Between the ferocious chirps of stellar mass pairs and the slow moans of supermassive binaries lies a domain reserved for space. A triangle of spacecraft trailing Earth will hold laser links millions of kilometers long. The constellation will be sensitive to hours-long waves. Extreme mass ratio in spirals will write calligraphy across these links. A small compact body will loop a giant thousands of times, each loop probing a slightly different radius and latitude. The accumulated phase encodes the multipoles of the spacetime, a test of whether the object matches the clean expectations of a rotating vacuum or hides extra structure. Supermassive black hole binaries in wide in spiral will drift through the band like distant thunder, warning of coalescences that other instruments may witness years later. Pulsar timing arrays listen for the hum of giants in chorus. Millisecond pulsars blink with regularity, unmatched by any man-made clock. Gravity waves passing between a pulsar and Earth stretch the path length in a pattern that depends on direction across the sky. Correlate the wanderings of many pulsars and the common signal emerges. The measured background hints at a cosmic census of supermassive pairs slowly spiraling through the last parsec. Its amplitude and spectral slope report on merger rates, on how often galaxies bring gas to the dance, and on whether environmental interactions stall the approach or shove the partners inward. Optical time domain surveys patrol for sudden meals. When a star strays too close, its unweaving brightens a galaxy for months. Space telescopes catch the soft X-rays and ultraviolet from the inner flow, while ground-based instruments record the emissions from gas further out. Radio arrays sometimes hear jets waking for a short, angry season. Each flare pins a mass to the center and fingerprints the appetite through color and tempo. Statistical collections of such events sketch the profile of sleeping engines in ordinary galaxies and the rate at which chance feeds them. Polarimetry adds a compass to the senses. At X-ray energies, polarization betrays scattering geometries and magnetic discipline near the corona. In the millimeter band, polarization spirals on maps of the inner flow, tracing fields that guide plasma close to the horizon. Across optical and infrared, dust grains aligned by magnetic fields twist the angle of polarization and reveal the shape of the veil that surrounds the engine. Each angle is a line of force drawn on the sky. Astrometry plays a quieter tune. Precise positions of radio cores wander by tiny amounts as knots are ejected in jets. Near a galactic center, stars map ellipses and rosettes around an invisible mass. Their periapses precess as relativity demands. Those small rotations measure the depth of the well and tease at the possibility of frame dragging if the witness stars approach close enough. Maser spots in circumnuclear disks orbit with Newtonian clarity and provide yardsticks to galaxies that would otherwise be guesses. All these witnesses need theory that can keep up. General relativistic magnetohydrodynamic simulations evolve plasma around spinning holes, threading it with fields and letting turbulence and reconnection burn. Ray tracing renders the photons those plasmas would launch into bent geodesics and draws synthetic images and light curves that can be compared to data. Parameterized tests relax the strict rules of the standard geometry by small controlled amounts and ask observations to rule in or out each deviation. The more instruments pile up agreement, the tighter those parameters shrink. Multi-messenger episodes tie the ears together. A gravitational wave chirp may appear first, warning that a massive union is at hand. Telescopes swivel to search for light, and sometimes they find only quiet because the surroundings are too clean. At other times, a long-watched nucleus changes mood after a suspected supermassive pairing shakes its disk. The timing is messy but enticing. Even when the mess resists a crisp link, the practice of chasing in several bands at once has turned serendipity into method. Precision is the temper of this listening. Arrays are phased to picoseconds. Mirrors are polished to nanometers. Clocks drift less in a year than a heartbeat does in a moment. Across that discipline, the darkness yields its outline, not a portrait with a face, but a set of constraints that press the unknown into a narrow corridor where imagination must walk straight. The weight is measured by orbit, the spin is drawn by lines in iron, the temperature of the inner furnace is tasted by echoes. The shape of the horizon is traced by crescents that refuse to widen or shrink beyond what geometry allows. The world has learned to hear gravity hum and to watch light stumble in its grip. From those stumbles and those hums, the contours of an unseen beast become a map with numbers instead of myths. Weather gathers where gravity eats. A ring of gas crowds a center that has no surface, and the ring does not stay quiet. Pressure flares, magnetic loops rise and snag. Ions and electrons argue in lightning that never sees air. From this quarrel, wines lift, and jets harden into spears. The scene is neither storm nor machine, yet it behaves like both, Appetite becomes meteorology, and the forecast reads in light. Closest to the brink spins a disk that is thin when the meal is moderate and thick when the rate swells. In the thin state, shear turns orbital energy into heat with scandalous efficiency. Turbulence is not guesswork. It is a specific instability that wakes whenever a weak magnetic field threads a differentially rotating flow. The magnetorotational instability takes a calm pattern of circles and, by exchanging angular momentum along field lines, turns it into transport. Fluid parcels hand off speed like runners in a relay until gas surrenders its outward support and glides inward. The energy shed on the way out of each orbit buys radiation, a blue-white swell for small engines and a violet to ultraviolet blaze for giant. Above the disk floats a corona of hot electrons, tenuous and fierce. Photons, born in the cooler layers below, dart upward and scatter from these electrons, climbing in energy. A power law tail grows in hard X-rays, a signature of Comptonization that rises and falls as the corona fattens or thins. Sometimes the hard light softens and the tail declines. Sometimes it surges, as if a patch of magnetic field has reconnected and dumped fresh heat into the halo. The balance between disk and corona changes the color of the engine like weather shifting from maritime grey to desert glare. When the accretion rate climbs, radiation pressures the disk and puffs it into a swollen funnel. Photons trapped by density ride with the gas instead of escaping cleanly. The inner regions thicken, shadows fall across their own edges, and the spectrum drifts to lower energies even as the power grows. At the other extreme, when the rate sinks, the flow turns hot and vertically extended, a lean geometry where radiative losses are poor and much of the heat is carried inward rather than out. In that regime, the jet often claims a larger fraction of the energy budget, an outflow fed by magnetic tension and suffering little radiative drag. Jets are the weather's most dramatic expressions. They diverge from the poles like lines drawn by a strict hand, narrow for light years, sometimes for millions of light years. Two engines can drive them. In one, magnetic fields anchored in the disk fling matter by centrifugal force along open lines, a wind that collimates into a beam once the field and inertia align. In the other, magnetic flux piles up on the horizon until the spinning hole must share. Rotational energy flows out along the field, and the jet becomes a conduit from the blackness itself. Power scales with spin and with the square of the accumulated flux. When the magnetic load is heavy, the flow enters a magnetically arrested state. In that mood, the jet brightens, the disk sputters, and variability grows muscular. Knots race along these beams with apparent speeds that scorn light only in appearance. Geometry and timing conspire to show superluminal motion when bright shocks move close to the line of sight. Polarization vectors pinwheel as shocks compress and order the magnetic field. Brightness surges where the jet slams into clumps, then fades where the pressure eases. Closer in, where resolution is scarce, timing becomes the lens. Delays between X-rays and radio, between optical and gamma rays, mark the yards between the corona, the launch point, and the first stable shock. Flares that cross bands in a set sequence tell of disturbances born near the inner rim and sprinting down the pipe. Winds peel from the disk at many altitudes. Some are warm, ionized breezes that leave narrow absorption lines on ultraviolet spectra, their speeds modest, their mass loss steady. Others are sudden gusts, ultra-fast outflows that bite at a tenth of light, stamped on X-ray spectra by blue-shifted iron. These fast streams carry momentum enough to rattle bulges and to heat the halos of galaxies. Where the outflow strikes dense gas, molecules shiver and glow in sub-millimeter light, a cold echo of hot intent. The mix of jet and wind becomes a thermostat for the host. Too much feeding at the core, and star formation is strangled. Too little, and the city of stars grows unchecked until gravity writes a correction in collisions and returns the food to the nucleus. Short timescales reveal the temperament. Power spectra of light curves show flicker that obeys simple laws. At low frequencies, variations carry most of the power, a restless wander that persists for days. At high frequencies, noise steepens, as if the engine refuses to improvise faster than orbits allow. Breaks in these spectra scale with mass and with feeding rate, turning the jitter itself into a mass meter. Echo mapping ties geometry to time. A burst in the hard continuum precedes a softening in the reflected spectrum, the delay measuring the height of the corona and the distance to the reflecting skin. As the engine changes mood, those delays shift, implying that the corona inflates or descends and that the inner disk breathes. Some systems fall into rhythms. A microquasar may throb with quasi-periodic oscillations that drift as the inner flow rearranges. Patterns emerge that invite identification with precession of tilted orbits, with wave modes trapped near the inner rim, with clumps circling and dissolving. A different cousin in a galactic nucleus can blink with quasi-periodic eruptions, minute-long outbursts recurring on hours, perhaps a small body grazing a disk and whipping up a miniature storm on every pass. Such clocks are never perfect. The slight wander in their periods is a confession that turbulence is always in the room. Polarization acts as a weather vane. In the millimeter band, maps of polarization near the silhouette show lines that coil or stream, telling where magnetic fields order the flow. Swings in angle during flares suggest that a knot orbits close to the horizon and drags its field around with it. In X-rays, the newly accessible polarization fraction and angle split corona models by geometry, picking between slabs, spheres, and patches of heated gas that glow in a checkerboard. Even in the optical, rotations of polarization during brightening hint at helical fields wound by rotation and unwound by reconnection. The interface between jet and medium stores memory. In clusters, cavities appear in X-ray maps where jets have inflated lobes and pushed hot gas aside. The work done is visible as buoyant bubbles that rise and fade over tens of millions of years. The energy invested balances the cooling that would otherwise condense gas into a storm of star-forming clouds. The engine and the atmosphere are partners in a long negotiation, with outbursts punctuating long quiets, a climate rather than a season. At small scales, reconnection near the inner rim produces impulsive heat. Electrons leap to higher energies and decorate the infrared with flares that flicker in minutes. The same episodes paint X-ray spikes. Polarization strengthens briefly, then relaxes, a sign that the field was ordered by a sudden squeeze, and then frayed by turbulence. Sometimes the flares walk in pairs, as if a magnetic loop snapped and, a moment later, its neighbor followed. The cadence is storytelling in amperes rather than words. Not all appetites look alike. Engines with high feeding rates show winds that can dominate the budget and suppress jets. Engines with lean diets show weak winds and strong beams. Orientation changes the reading. A beam pointed at the observer turns a modest power into a ferocious display, with apparent luminosity inflated by relativistic beaming. A beam pointed away leaves an archive of slower echoes in lobes and hotspots. Within one object, state changes shuffle the emphasis. A hard, jet-bright phase can switch in days to a soft, wind-bright phase. The trigger is a change in how the inner flow partitions energy between particles and fields. Spin writes a subtle signature. Where rotation is swift and magnetic flux is hoarded on the horizon, jet power grows. Where rotation is slower or flux is disordered, the beam weakens and the wind takes the stage. In some sources, precession of the inner flow nudges the jet to sweep a cone, carving S-shapes in radio maps and modulating brightness as the beam nods across our line of sight. The same precession can explain slow cycles in X-rays, a rocking of the corona that changes angles and optical depths as seen from the disk. Weather here is not random. It is governed by equations that couple gravity, magnetism, radiation, and motion. The forms feel familiar: gusts, beams, lightning, clouds. Yet they scale with mass and with spin and with the hoarded magnetic flux in ways that have no terrestrial analogy. Predictability is partial, as it is for any weather. The forecasts speak in probabilities, in power spectra and transfer functions, in population trends where one engine's tantrum becomes a point on a larger plot. Fear is a word borrowed from smaller storms. What happens here is closer to respect. The weather around a devouring mouth is a display of how rule and chaos braid. Jets write straight lines through intergalactic night, yet their brightness throbs as they collide with knots along the way. Winds strip gas from galaxies, yet they are launched grain by grain from the disorder of a magnetized disk. Flickers encode inner geometry, yet their pattern is always a little different, as if the engine enjoys improvisation within a strict key. Appetite, spin, and magnetic temper show themselves at last, not by opening the dark, but by making everything around it move. Time changes texture near a deep gravity well. Far from the pull, seconds fall one after another like clean beads. Close to the mouth, each second fattens and drags as if soaked in tar. A clock strapped to an orbiting probe reports the truth without drama. Its ticks spread apart for distant listeners, and light from those ticks swims redward, losing energy to the slope it must climb. The same truth writes itself on any pulse or flare. What begins crisp softens into a long fade. The simple act of approaching alters the grammar of duration. A diagram of light cones tells the story with geometry. In quiet space, each cone opens evenly, allowing many futures to point outward. Near the brink, the cone tilts. The allowed futures lean toward the center, and the outward tip narrows. At the surface of no return, the tip kisses the surface. Every allowed path falls inward. This is not a metaphor, but a statement about causality. Influence that once could escape is redirected. Causality does not break. It limps with a bias. It cannot overcome. The difference between two kinds of time becomes more than philosophy. Proper time is what a traveler feels along a path. Coordinate time is the bookkeeping used by a distant observer who keeps the ledgers for the entire stage. A freefaller reaches the horizon after a finite run of wristwatch seconds. The distant archivist never records the crossing. Instead, the final approach dilates into a sequence that thins into darkness. Both descriptions are complete within their frames. Each refuses to replace the other because light can carry only what geometry permits. Space and time trade habits in this neighborhood. Directions in space can harden into rules usually reserved for time. Infall becomes as inevitable as tomorrow. Meanwhile, a slice of time acquires the softness of space. Waiting longer does not rescue what has already crossed. This exchange is clearest in a rotating spacetime. Frame dragging forces anything nearby to participate in the spin. Within the static limit, standing still relative to the far stars is forbidden. Motion through time must include motion around the axis. The clock's ticks are braided with a compulsory swirl. Rotation deepens the puzzle. Outside the true surface of no return sits the ergosphere, a region where energy and time are entangled in a way that permits strange trades. A particle that splits there can send one fragment inward with negative energy, as measured at infinity, while the other escapes with a bonus. The accounting is flawless. The spin of the central mass pays the bill. Time's edge becomes a marketplace, where the future of one piece is purchased with the diminished future of another. The price is paid in rotation, slowed by the transaction. Even the act of looking is bent into a lesson about delay. Light that skirts the hole lingers near the photon sphere before escaping. Those glancing paths arrive late, as though the beam had dawdled. Hot spots in the inner flow appear, vanish, then reappear as echoes, their light split by different routes that take different measures of time. A flicker turns into a chord with several arrivals. Patience becomes a form of resolution. Waiting reveals circles that no telescope can draw directly. Causal diagrams attempt to domesticate these facts. Lines that represent possible histories terminate at the horizon for outward communication, but continue inward on the page until they end in a region where the theory hesitates to speak. Those pages also reveal curiosities within rotating solutions. Certain idealized paths loop in time in regions likely unphysical for real astrophysical bodies, either because instability ruins them or because matter would protest long before the geometry allows such loops to endure. The moral is cautious. Close to the brink, speculation multiplies faster than certainty, and the safe conclusions are those written in behavior that telescopes and detectors can weigh. In the presence of extreme curvature, chaos lurks with a schedule. Small differences in initial conditions near the inner rim grow exponentially with a pace set by gravity. The sensitivity has a bound expressed in a rate that temperature would set if the horizon were a thermal object. The bound is tight and the black hole sits on it. This is not an accident. It tells that the edge mixes information as fast as any process allowed by quantum mechanics. Time here does not merely stretch. It churns, scrambling inputs into patterns that are almost impossible to reverse. Acceleration adds its own color to the palette. An observer who insists on hovering just above the brink experiences a bath of particles that would be invisible to a free-faller. The difference is the path rather than the place. The heat belongs to acceleration. Time for the hovering witness is maintained by rockets and fuel. Time for the falling witness is maintained by surrender to the geodesic. The first labors in slow seconds warmed by effort. The second moves through ordinary seconds cooled by acceptance. There is a humbler effect at large distances that still carries the signature of delay. Signals passing near a mass arrive late, even if they never approach danger. Space along the route is not merely curved, time along the path is stretched. The lateness is tiny for an isolated star and colossal for a light ray that skims a throat. Astronomy measures both. The same principle that makes radio pulses wander on their way past a planet ensures that a photon produced near a fast orbit needs more patience to be heard. The inner orbits set clocks that do not read the same for every witness. A hot knot circling just outside the last stable track whips around in minutes for a stellar mass object, and in hours for a giant. Its period is a kind of proper time for that ring. The distant detector sees a longer story because the beat is rearranged by redshift, frame dragging, and light travel delays. It is possible to infer the proper rhythm by decoding the distorted song. In this way, an engine reveals its mass and spin by singing off key in a manner the equations predict. At the brink, entropy becomes a measure of area rather than volume. This turns time's arrow into something geometric. As the effective surface grows by swallowing, the count of hidden microstates grows proportionally. The direction in which cause accumulates effects aligns with the direction in which the horizon area tends to increase. Time acquires a preferred flow that is not merely human habit but a requirement of statistics and of gravity's book. Losses to the outside are paid in a coin called heat. Gains inside are recorded as increased area. Close to the end of an evaporating small black hole, the schedule speeds up. Temperature rises as mass falls, and the late phases concentrate their drama into a brief finale. This is a fantasy for astronomers in practice, since most black holes live in cold plenty and barely radiate. Yet the principle clarifies a paradox. What looks like a slow death to a distant audience may be ordinary experience for the system itself. Again, the description is loyal to a frame. Again, different frames refuse to merge into a single tale. The boundary between patience and impossibility becomes a practical concern for any imagined expedition. A message launched from near the horizon must claw outward for a very long time to be seen, and its energy declines with every moment spent in the climb. Planning a conversation across that gradient is like planning a conversation across centuries. The reply will come late and thin. A culture that tried would have to accept that meaning degrades with delay in a very literal way. Even memory is affected. A wave of gravity passing leaves a permanent shift in the distances between quiet test masses. The event itself is brief. The aftermath is forever. The same principle that allows a merger to write a lasting note into space-time suggests that journeys near a deep well leave indelible edits in the relations between events. Time keeps a diary near such places, and it writes in the positions of things. The edge is not a cliff, but a transformation. Seconds, there are not the same currency as seconds here. The knotting of futures is not a loss of logic, but a constraint that turns choice into a narrow corridor. Clocks do not lie. They speak different dialects according to altitude and motion. Cause does not vanish. It is forced to march along routes that find no exits. What unnerves is not cruelty, but insistence. The brink teaches that time is geometry wearing a watch, and that near a devouring mouth the watch face tilts until the numbers themselves begin to slide. He stands at the limit of understanding and looks inward without blinking. The dark engines that rule galactic hearts have no faces, no voices, no memories we can retrieve without patience bordering on worship. Yet they teach, and their lessons come engraved on the motion of stars, on the trembling of space-time, on rings of fire that outline an absence. The lesson changes a mind that accepts it. It trims pride, sharpens curiosity, and makes fear a form of respect. If nature has a cathedral, its altar is a horizon that refuses to share what passes through. If nature has a teacher, it speaks in curvature and silence, while everything around it answers with light. The first instruction is about scale. Human senses evolved for rivers and hills, for hours and seasons. Black holes ignore such units. They collect time into knots and pay in centuries for what a nearby star accomplishes in days. Their storms can stretch for millions of years, yet the decisive turns in their inner disks unfold in minutes. The mind adapts by building instruments that stand in for new senses, arrays that act like eyes the size of Earth, interferometers that turn distance into a violin string. Learning here is an act of humility disguised as engineering. The devices confess that flesh alone will not do. A second instruction concerns simplicity that is not simple-minded. A black hole outside its nearest environment can be named by 2 or 3 numbers. Mass sets the weight of the lesson. Spin tips the stage and drags frames into its dance. Charge could, in principle, decorate the summary, but the sky seems to drain it quickly. From such sparse description, a universe of consequences follows. Disks thicken or thin, jets ignite or fade, orbits precess and tides unweave stars. The spare inventory of parameters is not poverty. It is a clarity that turns prediction into a craft and pushes imagination to reconcile austerity with spectacle. There is instruction about truth and perspective. 2 witnesses narrate the same fall differently, and both are right. The traveller crosses a border in a handful of heartbeats. The archivist never sees that crossing, and instead watches the image dim into a red confession that arrives slower each moment. No argument resolves the difference. Geometry itself insists that both accounts are complete within their frames. This teaches a discipline rare in ordinary life. It asks that certainty be local, that pride in a view be tempered by the knowledge that a second map can be faithful and yet incompatible with the first. The world is not obliged to give a single version of events that satisfies every seat in the theatre. The lesson turns inward toward method. No one observation carries the meaning. A ring in millimeter light hints at a silhouette that matches ray tracings. X-ray echoes reveal a height for a hot corona that scatters softer photons. Broad lines in spectra bend with Doppler and gravity, sketching an innermost orbit. Gravitational waves announce masses and spins, with a chirp that ends in a tone set by the remnant alone. Each messenger is partial and biased. Together they draft a treaty between theory and sky that neither could write alone. The practice changes the temperament of inquiry. It punishes impatience and rewards synthesis. There is instruction about creation through destruction. A star torn into threads becomes a flare that enriches a halo with metals and nudges a sleeping nucleus awake. A jet drills a cavity in hot cluster gas and, by doing violence, saves a city of galaxies from sudden condensation and wasteful bursts of star formation. The engines at the centers are not merely consumers, they are regulators that turn hunger into structure. That identity replaces a childish fear of monsters with an adult recognition of duty. The dark centers are administrators with brutal tools. Their bureaucracy is gravity and magnetism. Their memos are winds and cavities, and their jurisdiction is measured in megaparsecs. The lesson brushes philosophy without apology. If information is preserved, then what looks like annihilation is accounting too subtle for any current mind to audit. The universe keeps books that balance even when the handwriting is hidden behind an event horizon. If evaporation returns details over long times, then forgetting is a posture, not a law. If interior and exterior descriptions are complementary, then truth comes with a clause about vantage. The monster, then, is not a glutton that chews without conscience. It is a vault that leaks with perfect arithmetic, returning what it gathered in a drizzle so fine that only an immortal librarian would smile. There is instruction in fear properly placed. Terror that freezes is a failure of scale. Courage that ignores is a failure of imagination. The appropriate mood near such objects is attention. The costs of inattention are written in the wreck of stars and in the jets that cut through galaxies. The costs of bravado are written in equations that do not bend for sentiment. To learn here is to accept that awe is not weakness. It is calibration. It sets the mind to the right sensitivity and tunes hope to the frequencies that data actually sing. The lesson continues with a curriculum in limits. There is no engine we can build that holds a frame steady close to the brink without paying a toll that tends to infinity. There is no message launched deep inside that returns to say how the center appears. There is no coordinate system so clever that it dissolves the difference between a smooth crossing and an eternal approach. Limits are not obstacles placed by reluctance. They are joints in the structure of reality. The mind that refuses to accept them breaks itself on geometry. The mind that accepts them grows precise. The teaching also concerns kinship. Black holes are not aliens in exile. They are outcomes of ordinary laws applied past ordinary conditions. The same gravity that holds a moon to a planet writes horizons around collapsed stars. The same magnetism that threads auroras orders jets into needles of light. The same turbulence that roughens air on a summer afternoon stirs disks into transport engines. Kinship grounds wonder. It says that the universe is one fabric, even where the weave grows so tight that the eye strains to follow it. A final instruction is about meaning without flattery. The cosmos does not arrange spectacles for attention. Flares and shadows are indifferent to applause. Human meaning grows by mapping these indifferent truths into stories that discipline motives and enlarge sympathies. The quiet power of a horizon can become a metaphor for privacy rightly kept, and for secrets returned only when the time is ripe. The stubborn fairness of a law that bends every path inward past a border can become a lesson about consequences that cannot be bargained with. The delicacy of extracting knowledge from echoes and hums can become an ethic of patience and partnership. He listens to the last silence, after a merger's ringdown fades, after a flare becomes a memory in a light curve, after a jet's knot slips beyond the field of view. What remains is not emptiness. It is the adjustment of the imagination to a universe that carries both mercy and perfection in how it obeys its rules. Black holes were once villains in fairy tales told with equations. Now they are tutors whose severity is matched only by their coherence. The most terrifying are the most instructive. They rule not with arbitrariness, but with geometry so flawless that it becomes a kind of kindness, because it can be learned. To stand at the edge of such knowledge is to feel small in the right way. He does not leave diminished. He leaves measured. The night remains vast, but it is less shapeless. The terror has been domesticated into reverence. What counts as progress is a better ear for hums, a sharper eye for crescents, and a steadier heart that can accept that the center of a galaxy is a maze that refuses rescue and still makes a city sing. The lesson is not how to survive a plunge. The lesson is how to live with horizons, how to work well knowing that some doors will not open, and how to love a universe that tells the truth, even when the truth is a silence ringed by light. Night folds over the page and leaves a patient glow where questions cooled. He does not carry a trophy from the dark, no fragment of a horizon in his pocket, no photograph that reveals a face. He carries measurements, timings, crescents that refuse to grow larger or smaller than law allows. He carries the weight of a number written as mass, the tilt of a number written as spin, the pause of a number written as delay between a flare and its echo. These are not trinkets. They are coordinates for humility. A galaxy turns like a quiet clock. Deep inside, an engine without surface governs with a certainty that never raises its voice. Jets draw straight lines that last longer than civilizations. Winds lift metals and seed futures in halos, where new stars will choose their languages. The lesson rides outward along these currents until even the outskirts of a cluster know the temperament of the center. A city of stars is a chord, and its root note is a gravity no ear can visit. He thinks of time as a fabric that remembers every pull. Mergers leave a memory that shifts distances by a whisper. Flares leave an accounting in the chemistry of gas far from the crime. The universe is not a theatre that forgets between acts. It is a ledger that keeps its pages forever. To live under such a sky is to accept that meaning gathers slowly, that patience is courage in another tense, and that silence is not absence but detail below the threshold. The last image is simple. A ring of light sits on the dark like a coin on velvet. Around it, stars behave as if a king were present, and perhaps that metaphor can be forgiven for one breath. Then the crown dissolves, and the metaphor is dismissed, leaving only geometry and gratitude. He closes the notebook. The night does not answer, yet it does not need to. It has already given what it gives, a rule that bends the world, and a chance to learn to bend with it without breaking.